Right now, as you listen to these words, sound is traveling through the air toward you. Invisible vibrations, moving at 343 meters per second, carrying meaning, emotion, and information directly into your consciousness. But have you ever wondered what sound actually is? Not just the physics of it, but what it means, why it moves us, why every human culture, without exception, creates music, why a single note can transport you to another time in your life, why the universe itself might be fundamentally made of vibration. These are the questions we'll explore together over the next 3 hours. I'm your guide on a journey through the philosophy of sound, a journey that will take us from ancient Greece to modern physics, from the biology of your ears to the far reaches of the cosmos. We'll discover that sound is not just one sensory mode among many. Sound is a window into the deepest mysteries of consciousness, reality, and what it means to be human. Along the way, you'll encounter mind-bending science, gravitational waves, quantum entanglement, the structure of atoms as standing wave patterns. You'll explore philosophical puzzles that have stumped thinkers for centuries. You'll learn why silence is never truly silent, why listening is an act of love, why beauty exists in a universe that doesn't require it. If you find yourself wanting to dive deeper into any topic, pause and reflect. Let the ideas settle. Before we begin, I'd love to know what brings you here. And if this journey resonates with you, subscribe to the Sleepy Mind Lab. We explore the most fascinating intersections of science, philosophy, and wonder. Now, settle in. Get comfortable. Whether you're listening before sleep, during a commute, or in a quiet moment of reflection, let's begin our exploration. The paradox of sound. Sound is one of the strangest phenomena in nature. It exists, impossibly, in 3 completely different places at once. First, there is sound in the world. Vibrations traveling through air, moving at about 343 meters per second on a calm day. These are measurable, objective oscillations that exist whether or not any ear hears them. Then there is sound in the body, the same vibrations striking the eardrum, triggering a cascade of mechanical events in the cochlea, converting physical waves into electrical signals. This is still physical, still measurable, still objective. And yet, there is a third sound, the experience of sound in the mind. The redness of a cello's tone, the warmth of a friend's voice, the terror inspired by a sudden crash. This experience is subjective, private, untranslatable. When you hear middle C, your subjective experience of that note belongs only to you. No one else will ever know exactly what it's like to hear it the way you do. Here is the puzzle. Which of these 3 is the real sound? Is it the vibration in the air? The signal in the nerve? The experience in consciousness? The answer seems obvious until you think carefully about it. We can measure the vibrations and the neural signals with perfect precision, but the experience itself remains forever beyond measurement, forever locked inside your private mind. This is not merely a curiosity. This gap between objective description and subjective experience is perhaps the deepest mystery in science. It appears in sound because sound is uniquely suited to reveal it. Other senses often hide this problem behind complexity, but sound makes it visible, and that visibility might teach us something fundamental about the nature of reality itself. Before words, the primordial listening. Long before humans had language, before we wrote stories or built civilizations, we listened. Archaeological evidence suggests that humans have been making music, intentionally creating sound, for at least 40,000 years. But listening surely came even earlier, deep in our evolutionary past. Imagine the first ancestor who could hear. What was that moment like? Before consciousness as we know it, before self-awareness, before meaning itself. Just pure sensation, vibration striking the ear, the brain responding, something registering as significant or insignificant. This primordial listening is the foundation of all human experience. It comes before sight. A human can be born blind and develop a rich mental world, but deafness from birth impoverishes language acquisition in profound ways. Listening seems more fundamental to consciousness than vision. Perhaps this is because sound reveals what we cannot see. It travels around obstacles, penetrates darkness, arrives from invisible sources. A rustle in the bushes we cannot see could be danger or nothing. The brain had to develop the ability to build a mental model of the world based on acoustic information. This act, taking invisible vibrations and constructing from them a sense of spatial reality, this is perhaps the first act of imagination. Before we could think abstractly, we listened. Before we could speak, we heard. And in that hearing, consciousness began to wake. The question is profound. Is listening something consciousness does, or is listening what consciousness is? Is awareness itself a form of listening, the universe becoming aware of itself through the act of attending to vibrations? The invisible made manifest. Imagine living in a world where only one sense worked, vision. You would see the world clearly, but only what light reached your eyes. You would miss everything hidden behind walls, everything in darkness, everything outside your line of sight. You would understand only surfaces. Then, sound gives you something impossible, information about things you cannot see. A voice comes around a corner before the person appears. Thunder reveals the existence of a storm beyond the horizon. The heartbeat of someone you embrace tells you they are alive, that blood moves through their body. Sound penetrates barriers that stop light. It bends around obstacles. It travels through solid matter. An ultrasound can peer inside a body and reveal the presence of a growing child. A seismograph listening to the Earth's vibrations reveals the hidden structure of our planet's interior. We have never seen the Earth's core, but we have heard it, translated its vibrations into images. This property of sound, that it reveals the invisible, is more philosophically significant than we usually appreciate. It suggests that reality extends far beyond what we can see. The visible world is merely the surface. Sound gives us access to the hidden dimensions of existence. And this raises a question. What other invisible aspects of reality are we missing? What vibrations exist that we have no organs to detect? What information about existence travels through the universe unheard, never reaching any conscious listener? Sound teaches us that the real world is far stranger and richer than the world of appearances. Silence as a philosophical problem. 433. What is silence? This simple question becomes very strange when you think carefully about it. We usually say, silence is the absence of sound. But if that's true, then silence is nothing. It's just the lack of something. And yet, silence is deeply present to us. We feel it. We can create it deliberately. We can appreciate it aesthetically. Musicians use silence. John Cage's famous composition 433 consists entirely of silence. The performer sits at the piano and does nothing for 4 minutes and 33 seconds. And yet, audiences listen intently. What are they hearing? They hear the ambient sounds of the concert hall, air conditioning, distant traffic, people shifting in their seats, their own heartbeat. Silence, it turns out, is never truly empty. It is full of micro-sounds our consciousness usually filters out. Cage's insight was that by removing intentional music, he revealed the soundscape we normally ignore. This reveals something profound. Perception is selective. We choose what to notice. The world is infinitely rich with information, but consciousness is a narrow spotlight that illuminates only a fraction of it. Silence, then, is not the absence of sound. It is the absence of attended to sound. And this raises the deepest question. How much of reality exists unattended, unheard, literally unperceived? When you're not hearing something, does it still exist? Physics says yes, but philosophy asks, in what sense does unperceived reality exist? Silence is the philosophical problem made audible. The act of listening as intellectual engagement. To listen truly is one of the rarest things we do. Most of the time we hear without listening. Sound washes over us, but we don't attend to it. We hear music at a coffee shop but pay no conscious attention. We hear someone speaking while we're thinking about something else. Real listening is different. Real listening requires silence in the self. You must quiet your own thoughts, suppress your urge to respond, release your plans for what you'll say next. You must create an internal space for the other person's words. This act has consequences for consciousness itself. When you listen carefully, your brain enters a different mode of operation. Brain imaging shows that active listening engages the same neural networks involved in theory of mind, the ability to imagine what someone else is thinking and feeling. Listening, in other words, is an act of imagination. You are literally constructing in your mind a model of another person's interiority. You are, for a moment, becoming partly them. This is why deep listening is sometimes described as an act of love. It is the recognition of another consciousness, another inner world as real as your own. And this matters because it suggests that understanding, real understanding of another person, another perspective, another truth, begins with the willingness to listen. All knowledge begins with listening. Science begins when someone listens carefully to what nature is saying through experiment. Philosophy begins when someone listens to the deepest questions and refuses easy answers. Consciousness itself might be fundamentally about this capacity to listen, to attend, to receive what is offered from beyond the boundaries of the self. Pythagoras and the mathematics of sound. Around 500 BCE, on the island of Samos, a Greek philosopher named Pythagoras made a discovery that would reshape human understanding of reality itself. He was walking past a blacksmith shop when he heard something remarkable. The ringing of hammers on anvils seemed to produce harmonious sounds. Different hammer weights, he realized, created different tones, and these tones were not random. They related to each other in precise mathematical ratios. Pythagoras became obsessed. He constructed a monochord, a simple instrument with a single string and a movable bridge. By plucking the string at different lengths, he could produce different notes. When he shortened the string to exactly half its length, the note jumped up by an octave, a sound perfectly pleasant to the human ear. When he used 2/3 of the string, he got a perfect fifth. When he used 3/4, a perfect fourth. These weren't arbitrary preferences of human ears. These were mathematical relationships woven into the fabric of sound itself. What Pythagoras had glimpsed was revolutionary. The universe operates according to mathematical principles, and sound is one of the clearest ways to perceive these principles. The discovery was so profound that it launched a new way of thinking about reality. If music follows mathematical laws, perhaps all of nature does too. Perhaps mathematics is not something humans invented to describe reality, but something fundamental to reality's structure. For Pythagoras, this meant the universe was fundamentally rational, comprehensible through reason and mathematics. Sound became the proof that mind and matter speak the same language. But there was something even deeper here. Pythagoras was showing that what we experience as beautiful, harmonious intervals, consonant chords, corresponds to what is simple in mathematics. Beauty, he suggested, is simplicity revealed to the senses. This idea would echo through all of Western philosophy and science. The notion that truth, beauty, and mathematical simplicity are connected still guides physicists today. When they seek a theory of everything, they assume it will be elegant, economical, beautiful. Sound taught them this lesson first. Why every culture discovered music independently. Here is a remarkable fact that most of us never think about. Every single human culture that anthropologists have ever studied makes music. Not some cultures, all of them. From the most isolated indigenous peoples of the Amazon to the Arctic, from the deserts of Australia to the mountains of Nepal, humans everywhere create organized sound. This is not a cultural accident. This is not something borrowed from neighbors or taught by traders. The archaeological record shows musical instruments appearing independently in different parts of the world, separated by thousands of years and thousands of miles. Bone flutes from 40,000 years ago have been found in caves in Germany. Percussion instruments appear in the archaeological record of Africa at similar timescales. The question becomes unavoidable: why is music universal? What does this tell us about the human brain? One answer comes from neuroscience. Music activates multiple brain systems simultaneously. It engages motor regions, emotional centers, memory circuits, language processing areas. A single piece of music can make you move, feel, remember, and think all at once. This integration of different brain systems might be deeply rewarding at a neurological level. Perhaps the human brain is built in such a way that creating organized sound feels intrinsically good. But there's something deeper here. Music is the only human universal activity that serves no obvious survival purpose. We eat because we need nutrition. We reproduce because we need to propagate genes. We form groups because groups provide safety and resources. But music? A lullaby doesn't provide calories. A love song doesn't improve survival chances. Yet humans invest enormous time and energy in making music. This suggests that consciousness seeks meaning and beauty for their own sake. We are not purely survival machines. We are creatures who create beauty because the creation of beauty is, in itself, meaningful. The universality of music reveals something essential about what it means to be human. We are the animals that ask why, and we answer that question through art. Yes. Harmony as early physics. The ancient philosophers did not have microscopes or oscilloscopes. They could not measure sound waves or analyze frequencies. And yet, through careful observation and logical reasoning, they were conducting a form of physics. When the Pythagoreans studied musical intervals, they were actually doing experimental science. They had a hypothesis that musical beauty corresponds to mathematical simplicity. They had a method, plucking strings at different lengths. They had results, specific ratios that consistently produced pleasant sounds. They drew conclusions that became models for understanding all of nature. This approach extended far beyond music. Plato theorized that everything in the physical world is composed of tiny geometric forms. He didn't have evidence. Evidence would come millennia later, but he was intuiting something true. That the universe operates at scales too small to see, according to mathematical principles. Aristotle observed that sounds travel through air and water, and he theorized about the nature of sound propagation. He was wrong in details, but correct in intuiting that sound required a medium. The ancient philosophers were reaching toward physics through reason and observation. Sound was uniquely useful for this because it's invisible, yet its effects are obvious and measurable. When you pluck a string, you cannot see the vibration, but you hear the result. The invisible becomes manifest. This made sound a perfect teacher of how to think about nature. The ancients learned from sound that reality has layers. There's the level we perceive directly, the sound we hear. But beneath that perception lies a deeper level, the vibrations that cause the sound. And beneath the vibrations lies mathematics itself, the ratios and relationships that determine which vibrations occur. This layered view of reality where observable phenomena arise from hidden causes, which themselves follow mathematical laws, became the template for all modern science. We see it in how physicists talk about quarks and fields, in how biologists talk about genes and proteins. We inherited from ancient sound studies the deep intuition that reality is fundamentally mathematical and hierarchically structured. The problem of perception, Plato's cave and sound. In Plato's famous allegory of the cave, prisoners are chained facing a wall where they see only shadows cast by a fire. They mistake these shadows for reality. One prisoner escapes, emerges into sunlight, and realizes the shadows were illusions. He returns to tell the others, but they mock him. This allegory is about perception and reality, but Plato himself used sound to illustrate the puzzle even more clearly. Imagine the prisoners hear only echoes bouncing off the cave wall. They would hear sounds and attribute them to the shadows, but the sounds actually come from people outside the cave, unseen and unrecognized. How would the prisoners know their acoustic perception was distorted? They would have no way to check their impressions against reality. This scenario isn't merely theoretical. It describes a genuine problem with human perception. We never perceive reality directly. We perceive representations, shadows, echoes, sensations. We construct our sense of reality from these representations. And we have no way to step outside our perceptions to verify they match an external world. This is the epistemological problem that launched modern philosophy. Descartes, centuries later, would use this puzzle to argue that the one thing we cannot doubt is that we are thinking, because even in doubt, we are thinking. But sound makes the problem especially vivid. Sound is always an echo in some sense. It's a vibration that reaches your ear, already transformed by its journey through space. The original event that caused the sound has passed. You never perceive the vibration itself. You perceive only its effects on your body and mind. Yet from these effects, you construct a detailed model of a world beyond your body. A friend speaks, and you hear not just sounds but meaning, personality, emotion. You hear intention. You hear a person. How do you make this leap from raw sensation to understanding another mind? This is the ancient question that sound reveals. And perhaps the answer is that perception is not passive reception, but active construction. You don't just hear sound, you interpret it. Your brain is constantly building models of reality and testing them against incoming information. Sound, traveling invisibly through space and arriving at your ear, is information that your mind must actively decode into meaning. The evolution of the ear, why we hear what we hear. The human ear can detect frequencies from about 20 Hz to 20,000 Hz. But this range is not universal. Dogs hear up to 65,000 Hz, ultrasound that we find completely inaudible. Elephants hear as low as 14 Hz, infrasound below the range of human perception. Bats navigate using frequencies around 100,000 Hz, far beyond what any human could detect. Each species hears a different slice of the acoustic spectrum. Why? The answer lies in evolutionary fitness. Humans evolved the hearing range we have because these frequencies were most important for survival and reproduction. Infrasound below 20 Hz is rarely produced by animals or natural events relevant to human life. We can feel very low frequencies as vibrations in the body, but we don't need to hear them crisply. Ultrasound above 20,000 Hz is similarly uncommon in our natural acoustic environment. Our range is perfectly tuned to the world we inhabit, the sounds of other humans, of predators and prey, of weather and geological events that threatened our ancestors. But our hearing range is also tuned to something deeper, human speech and music. The frequencies that convey the richest information in human language fall squarely in our optimal hearing range. the emotional content carried by the human voice. Prosody, tone, timbre, relies on frequencies we hear most clearly. This cannot be accident. Our ear evolved to hear human communication with crystalline clarity. And this reveals an astonishing fact. We are built to listen to each other. Our biology is structured to prioritize the sounds of other minds. The evolutionary pressure that shaped our hearing came not primarily from needing to detect predators or prey, but from needing to understand each other. We are the social animal that depends on acoustic communication. Our ear is an instrument designed by millions of years of evolution to receive the voices of others. This suggests that listening is not peripheral to human nature. It is central. We evolved to listen, and perhaps consciousness itself is, in part, an adaptation for receiving and understanding the minds of others through the medium of sound. Galileo's pendulum and the rhythm of time. In the early 1600s, Galileo Galilei was sitting in the Cathedral of Pisa during a service. Above him, a chandelier swung back and forth. According to legend, he timed the oscillations using his own heartbeat. What he discovered was that the period of the swing, the time it took to complete one full oscillation, remained constant whether the chandelier swung in wide arcs or small ones. This observation launched modern physics. The key insight was that vibration follows mathematical laws. The motion of the pendulum could be described precisely using geometry and mathematics. This meant that the invisible forces governing motion could be made visible through mathematical description. Galileo realized something profound. The universe speaks mathematics. Not metaphorically, but literally. The patterns of nature can be expressed as equations. This was revolutionary. It meant that natural phenomena were not arbitrary or mystical. They were comprehensible through reason, and sound was one of the clearest examples of this principle. When a string vibrates, it produces sound. The frequency of vibration, how many times per second it oscillates back and forth, determines the pitch we hear. Double the frequency, and you jump up an octave, exactly as Pythagoras had discovered. But now this could be measured precisely. It could be expressed mathematically. Sound became a gateway to understanding how nature operates at a fundamental level. What Galileo and the scientists who followed him realized was that vibration is everywhere. The pendulum vibrates. Strings vibrate. Air molecules vibrate when sound travels through them. Light, it would later be discovered, is vibration too. Vibration seemed to be one of nature's primary mechanisms. And vibration follows mathematical laws. This insight transformed how humans understood reality. Before Galileo, nature seemed governed by purposes and intentions. Things happened because of divine will or natural inclinations. After Galileo, nature seemed governed by mechanical laws and mathematical relationships. The universe was less like a conscious being with intentions, and more like a vast machine operating according to precise rules. This shift in worldview was as profound as any philosophical revolution. And it began with watching a chandelier swing and realizing that its rhythm was not random, but lawful. The speed of sound, a chase across time. For most of human history, people assumed sound was instantaneous. When you shouted, the sound reached someone's ear immediately. There was no perceptible delay. It wasn't until the early 1600s that scientists realized sound actually takes time to travel. This discovery was shocking. It meant sound was not fundamentally different from other phenomena. It had a speed. In 1660, a French scientist named Marin Mersenne measured the speed of sound by firing a cannon and timing how long the sound took to reach observers at different distances. He calculated approximately 350 meters per second, remarkably close to the modern value of 343 meters per second in air at room temperature. What made this discovery philosophically significant was what it implied. Light had also been assumed to travel instantaneously. But if sound had a finite speed, perhaps light did too. This opened a radical question. Is there a universal speed limit in the universe? Centuries later, Einstein would discover that yes, there is, and it's the speed of light, about 300,000 kilometers per second. Light is much faster than sound, which explains why we see lightning before hearing thunder. But the principle is the same. Both are waves that travel at finite speeds. Measuring the speed of sound did something else. It made the invisible phenomenon of sound partially visible. Sound, which travels invisibly through air, could now be quantified. Its behavior could be predicted. If you knew how far away a sound source was, you could calculate exactly when the sound would arrive. This predictability suggested that sound was not mystical, but mechanical. It was simply a disturbance propagating through a medium according to physical laws. Yet this raised a new mystery. If light also travels at a finite speed, and if light is a wave, what is light waving in? Sound waves propagate through air. The medium is obvious. But space is mostly empty. What medium carries light? Scientists theorized an invisible substance called the ether that filled all of space. Light, they thought, must be waves in this ether. It took Einstein to realize the ether didn't exist. Light needs no medium. It is something fundamentally different from sound. This discovery revolutionized physics and our understanding of reality itself. But it all began with measuring the simple fact that sound takes time to travel. Descartes and the ghost in the machine. René Descartes was one of history's greatest philosophers, but he also struggled with a problem that science had created. If the physical world operates according to mechanical laws, like a machine, what about mind and consciousness? Where do they fit into this mechanical universe? Descartes was deeply troubled by sound. When sound waves strike the ear, they trigger a mechanical cascade. Vibrations in the eardrum, fluid waves in the cochlea, electrical impulses along the auditory nerve. All of this is mechanical. All of it can be described in terms of matter, in motion. But the experience of sound, the sensation of a note, the emotional impact of music, seemed to require something non-mechanical. It seemed to require mind. Descartes proposed a solution that became famous as the problem of mind-body dualism. He argued that there are two kinds of substance in the universe: matter, which is mechanical and extended in space, and mind, which is immaterial and conscious. The body is a machine. The mind is something else entirely. They interact, but they are fundamentally different. This seemed to solve the problem of sound. The vibrations are mechanical, matter in motion. But the experience of sound is mental. Consciousness receiving and interpreting these vibrations. Yet this solution created a new puzzle. How can immaterial mind interact with material body? How can the ghost get into the machine? This problem haunted philosophy for centuries. And sound, more than any other phenomenon, reveals the puzzle clearly. We can describe with perfect precision what happens physically when you hear a note. We can map the neural correlates of hearing. We can show exactly which brain regions activate. But we cannot explain why all these physical processes feel like something. Why does hearing middle C feel like hearing middle C and not like something else, or nothing at all? This is what philosophers call the hard problem of consciousness. And sound reveals it most vividly. The physical description of sound, vibrations, frequencies, neural signals seems complete and yet profoundly incomplete. It misses something essential, the subjective experience itself. Perhaps Descartes was right that this gap cannot be bridged by physics alone. Or perhaps we are missing something fundamental about how consciousness and matter relate. Either way, sound forces us to confront this mystery. Newton's universe of waves. Isaac Newton transformed our understanding of light and gravity, but he also proposed something revolutionary about sound. In the 1680s, working on his monumental Principia Mathematica, Newton developed the mathematics of wave propagation. He showed that sound, like light, behaves as a wave. Waves have properties: wavelength, frequency, amplitude, velocity. All of these can be expressed mathematically. Newton's insight was that waves in different media follow the same mathematical principles. A wave in water, a wave in air, a wave in air, a wave in a rope, all obey the same equations. This suggested something profound. There might be a universal mathematics of waves that applies to all phenomena. Newton thought of waves in terms of a medium. Water waves need water. Sound waves need air or some other material to vibrate. But Newton knew light travels through the vacuum of space. So he proposed that light travels through an invisible medium called the luminiferous ether. This ether filled all of space, and light was waves in this ether. This theory seemed to solve everything. Both light and sound were waves. Both obeyed mathematical laws. Both required a medium. The universe operated according to unified principles. But there was a problem. If light travels through the ether and Earth moves through space, then the speed of light should be different, depending on which direction you measure it. Just like sound is faster if you're moving toward the sound source than if you're moving away. But experiments showed that the speed of light is always the same, no matter which direction you measure it or how fast you're moving. This was a profound mystery. It seemed to violate the principles of relativity. Something was wrong with the ether theory. It would take Einstein to resolve the puzzle. He proposed that light doesn't need a medium. It's not waves in an ether. Light is something fundamentally different: electromagnetic radiation that can propagate through empty space. This realization transformed physics. It showed that Newton's intuition about waves needed refinement. Sound and light, while both wave phenomena, are fundamentally different. Sound requires a material medium. Light does not. This difference revealed something about the deep structure of reality. There are different kinds of waves, different kinds of vibration, operating according to different rules. The universe is far stranger than the mechanical clockwork Newton imagined. The birth of acoustics, making sound measurable. By the 1800s, scientists had developed the tools to study sound with precision. Tuning forks, metal instruments that vibrate at specific frequencies, became essential laboratory equipment. They allowed researchers to generate pure, measurable tones. Ernst Chladni, a German physicist working in the early 1800s, invented a technique that made sound visible. He sprinkled fine powder on a metal plate and drew a bow across the edge, causing it to vibrate. The vibrations created standing wave patterns, and the powder collected at the nodes, the points where the plate was motionless. What emerged were beautiful, intricate geometric patterns unique to each frequency. These patterns revealed something astonishing. Sound has structure. It has geometry. The invisible phenomenon of sound, when translated into visual form, revealed elegant mathematical order. Chladni patterns showed that vibrating objects don't vibrate randomly. They vibrate in specific modes determined by their shape and material properties. A round plate vibrates differently from a square plate. Thicker material vibrates differently from thin. Each geometry produces its own characteristic pattern. This discovery suggested that sound was not chaotic or arbitrary. It was lawful and ordered. The mathematician Leonhard Euler developed equations describing how sound waves propagate through different media. The physicist Joseph Fourier discovered that any complex sound wave could be broken down into simple sine waves, pure tones at specific frequencies. This meant that even the most complicated sound, a symphony, a human voice, was fundamentally a combination of simple harmonic vibrations. Fourier's insight was revolutionary. It meant that complexity could be reduced to simplicity through mathematical analysis. The universe, it seemed, built all its complexity from simple harmonic building blocks. This principle would prove far more general than just sound. Light could be decomposed the same way. Matter itself, quantum physics would later reveal, consists of vibrating fields. Fourier analysis became one of the most powerful tools in science. And it all began with studying sound, making the invisible vibration visible through powder patterns and mathematics. By the end of the 1800s, acoustics had become a mature science. Sound was no longer mysterious. It could be measured, analyzed, predicted, and controlled. Yet in solving the mysteries of sound's mechanics, a deeper mystery emerged. Why does all this mechanical complexity produce subjective experience? The more we understood the physics of sound, the more puzzling consciousness became. Frequency, the language of existence. Consider a simple fact. Everything vibrates. An atom vibrates. A molecule vibrates. Electrons orbit nuclei in patterns that resemble oscillation. Light vibrates. The fabric of space-time itself, according to Einstein, can vibrate. These are gravitational waves. Even the most solid-seeming matter is, at its foundation, oscillation. The universe speaks in frequencies, and we occupy just one narrow band of this vast spectrum. Human ears detect frequencies from about 20 Hz to 20,000 Hz. But this is a tiny sliver. Below our hearing range lies infrasound, the deep rumbling below 20 Hz. Whales produce infrasound that travels across entire ocean basins. Elephants communicate with infrasound, felt more than heard. Some birds navigate using infrasound generated by wind over mountains. The Earth itself vibrates at infrasound frequencies during earthquakes and storms. We cannot hear these frequencies, yet they carry crucial information about the world. Above our hearing range lies ultrasound, frequencies above 20,000 Hz. Bats navigate using ultrasound, emitting clicks at 100,000 Hz or higher and listening for echoes. Dolphins use ultrasound for echolocation and communication. Insects communicate with ultrasound. Medical ultrasound machines use these frequencies to peer inside bodies. Somewhere between infrasound and ultrasound lies our human window. We evolved to hear the frequencies most relevant to our survival: the human voice, animal calls, environmental sounds. But we live in an acoustic world vastly richer than our ears can access. This raises a philosophical question. What other information is traveling through the universe that we have no organs to detect? The electromagnetic spectrum extends far beyond visible light. We cannot see infrared radiation, yet thermographic cameras reveal heat signatures. We cannot see ultraviolet light, yet it burns our skin and kills bacteria. We cannot see radio waves, yet they fill the air around us, carrying conversations and music. Sound is just one example of how perception carves a narrow window into reality. The full spectrum of vibration is far larger than any individual species can perceive. This suggests that the true nature of reality, the complete picture of how energy and matter move through the universe, is mostly hidden from us. We see only what we're equipped to see. We hear only what we're equipped to hear. The rest remains invisible, inaudible, unknown. Yet it's still there, still real, still affecting the world. Sound teaches us humility. It reminds us that our perception is parochial, limited, shaped by evolutionary accident rather than objective truth. The Doppler effect, time and motion revealed through sound. Imagine standing on a platform as a train approaches, blowing its whistle. As the train comes toward you, the whistle sounds higher in pitch. Once it passes and moves away, the pitch suddenly drops lower. This everyday experience reveals something profound about sound and reality itself. The phenomenon is called the Doppler effect, named after the Austrian physicist Christian Doppler, who explained it in 1842. Here's what's happening. As the train approaches, it compresses the sound waves. The distance between successive wave crests decreases. This means more waves reach your ear per second, which translates to a higher frequency and thus a higher pitch. As the train recedes, it stretches the sound waves. The distance between wave crests increases. Fewer waves reach your ear per second, lowering the frequency and pitch. What makes this philosophically significant is that the Doppler effect reveals how motion and perception are entangled. The actual sound produced by the whistle doesn't change. The whistle produces the same frequency regardless of motion. But what you perceive changes based on the relative motion between source and observer. This means that perception of sound is not just about the object being perceived, it's about the relationship between observer and object. Sound reveals motion through pitch. This principle became crucial to astronomy. If light from distant stars shows a Doppler shift, astronomers can determine whether those stars are moving toward us or away from us. Redshift, light shifted toward lower frequencies, indicates recession. Blue shift indicates approach. Using this principle, astronomers discovered that distant galaxies are moving away from us. Moreover, galaxies farther away are moving faster. This observation led to the conclusion that the universe is expanding. And this observation led, ultimately, to the Big Bang theory. The expansion of the universe, the discovery that our universe had a beginning and might have an end, followed from understanding sound's Doppler effect. But there's a deeper philosophical point. The Doppler effect shows that reality is fundamentally relational. There is no absolute pitch to the whistle, only the pitch as perceived from a particular vantage point. There is no absolute color to light, only the color as perceived from a particular frame of reference. Observers in different states of motion perceive reality differently. This insight, drawn from sound, became foundational to Einstein's theory of relativity. Relativity shows that time itself is relative. Observers in different states of motion experience time differently. Space and time are not absolute containers in which events occur. They are relational, dependent on the observer. Sound, through the Doppler effect, taught physics that reality is not objective in the way Newton imagined. Reality is participatory. Observer and observed are entangled. Resonance, when objects vibrate together. Place two tuning forks of identical frequency near each other. Strike one, making it vibrate. After a moment, the other will begin to vibrate too, even though you haven't touched it. The vibrations have transferred through the air from one fork to the other. The second fork literally resonates with the first. This phenomenon is called resonance, and it might be the most important principle in all of physics. Resonance occurs when an oscillating system encounters another system that vibrates at the same frequency. When frequencies match, the oscillations reinforce each other. The amplitude grows. The vibration becomes stronger, more visible, more powerful. Resonance explains countless phenomena. It explains why a singer can shatter a glass by hitting the right note. The sound vibrations at the glass's natural frequency cause the glass molecules to oscillate with increasing amplitude until the material fails. It explains why soldiers break step when crossing a bridge. Synchronized footsteps can cause the bridge to resonate, potentially causing catastrophic failure. It explains why certain rooms have frequencies where sound amplifies and others where it deadens. But resonance has deeper significance than these practical examples. Resonance suggests that the universe is fundamentally relational. Objects don't exist in isolation. They exist in relationship to other objects. When two systems have compatible vibrational patterns, they influence each other. Energy transfers between them. They become coupled. This principle extends far beyond sound. In quantum mechanics, particles can only interact at certain resonant frequencies. Chemical bonds form when electron orbitals resonate with each other. Atoms bond because their electron clouds have compatible vibrational patterns. Molecules form from atoms that resonate together. Life itself depends on resonance. Proteins fold into specific shapes because different parts of the protein resonate with each other and with their molecular environment. The universe, at every scale, is made of resonating systems. Things that resonate with each other naturally attract and bind. Things that don't resonate remain separate. This suggests something philosophical. Reality might be fundamentally about compatibility and harmony. The universe doesn't consist of isolated particles bumping together randomly. It consists of systems that find each other, resonate together, and create larger unified structures. Resonance is how the universe builds complexity. It's how singularity becomes multiplicity. A single vibration, spreading through a medium, can activate countless resonators. And once activated, these resonators can influence each other, creating interference patterns, standing waves, and complex structures. From this perspective, resonance is not just a physical phenomenon. It might be the fundamental principle of existence itself. Destructive interference, sound cancelling itself. Here is one of the most counterintuitive phenomena in physics. Two sounds can cancel each other out completely. If you have two sound waves with identical amplitude but opposite phase, one compressed where the other is rarefied, they will annihilate each other. Where one wave says, "go up," the other says, "go down" with equal force. The result is silence. This phenomenon is called destructive interference, and it seems to violate our intuition. We imagine that adding more sound to sound should produce more sound. But under the right conditions, adding sound produces nothing. This principle is now used in noise-cancelling headphones. Microphones outside the headphone pick up ambient noise. Electronics in the headphone generate an inverse sound wave, the exact opposite of the incoming noise. When played through the speakers inside the headphone, the original noise and the inverse wave meet and cancel. The result is silence. It's genuinely remarkable. You've created silence by adding a sound. The mathematics of destructive interference teaches something profound. The universe operates through opposites. Positive and negative, compression and rarefaction, up and down. These opposites can either amplify each other, constructive interference, or annihilate each other, destructive interference. The outcome depends on the phase relationship, whether the opposites are aligned or misaligned. This principle extends to light, where constructive and destructive interference create the patterns of diffraction. It extends to matter, where quantum particles exhibit wave-particle duality precisely because of interference patterns. And philosophically, it suggests something about the nature of being and non-being. Existence and non-existence are not absolute categories. They emerge from the interference of opposing forces. Where opposing forces amplify, existence strengthens. Where they cancel, existence weakens to nothing. This is reminiscent of ancient philosophical intuitions, the yin and yang of Taoism, where opposite forces create dynamic balance. But destructive interference shows this isn't merely poetic metaphor. It's precise mathematics. Reality at its foundation operates through the interaction of opposites. And silence is not the absence of sound. Silence is the perfect balance of opposed sounds. It is active, not passive. It is the result of forces cancelling, not of forces being absent. This reframes how we think about emptiness and nothingness. They are not mere voids. They are the product of perfect opposition and balance. The physics that seems like magic. Certain phenomena in acoustics seem to defy intuition so thoroughly that they feel almost magical. Consider the shepherd tone, a sound illusion discovered in 1964 by cognitive scientist Roger Shepard. A shepherd tone sounds like a single pitch continuously rising. You hear it go higher and higher. And yet, if you listen long enough, you realize it has returned to where it started. The pitch appears to rise infinitely, yet it cycles back to the beginning. This is possible because the shepherd tone is actually multiple overlapping sine waves. As the high-frequency component fades out, a new low-frequency component fades in. Your brain hears the high frequencies and perceives rising pitch, but it doesn't notice the low frequencies entering below the threshold of perception. When the illusion cycles, you're back where you started, but your brain is tracking the high frequencies, so it perceives continued rising. The illusion works because it exploits how human brains process sound. We don't hear sounds in isolation. We hear them relative to context. We hear change, and our brains make assumptions about how sound should evolve. When reality violates our assumptions in just the right way, we perceive illusions. Or consider acoustic levitation, the use of sound waves to suspend objects in air without physical support. Ultrasonic waves create standing wave patterns. At certain nodes in these patterns, the acoustic radiation pressure can suspend a small object. The object floats in mid-air, held up by nothing but sound. Or consider harmonic overtones. The fact that when a string vibrates, it doesn't vibrate at just one frequency. It vibrates at a fundamental frequency, and also at all integer multiples of that frequency. A string vibrating at 100 Hz also vibrates at 200 Hz, 300 Hz, and so on. These overtones blend with the fundamental to create the unique timbre of the sound. This is why a piano note sounds different from a violin note, even at the same pitch. The mathematics of overtones reveals that purity is an illusion. Everything that vibrates does so at multiple frequencies simultaneously. Complexity is built into simplicity. These phenomena, shepherd tones, acoustic levitation, harmonic overtones, aren't truly magical. They're physics. But they reveal that physics itself is far stranger and more subtle than intuition suggests. The universe has tricks we never anticipated. Sound reveals the hidden sophistication of how vibration operates, and in that revelation, we glimpse how much we still don't understand about the nature of reality. The ear as an engineering marvel. Imagine a structure so intricate, so precisely engineered, that it can detect vibrations as small as 1 nanometer, a billionth of a meter. Imagine a device so sensitive that it can distinguish between two sounds that differ in frequency by less than 1%. Imagine an instrument that responds logarithmically to sound intensity, allowing us to hear both a whisper and a jet engine without our perception being overwhelmed by the jet. This is the human ear. The ear consists of 3 main chambers. The outer ear is a funnel that collects sound and channels it down the ear canal. The middle ear contains 3 tiny bones, the hammer, anvil, and stirrup, that vibrate in response to the eardrum and mechanically amplify the signal before sending it to the inner ear. The inner ear contains the cochlea, a spiral structure filled with fluid. When sound vibrations reach the cochlea, they create traveling waves in the fluid. These waves stimulate hair cells along the basilar membrane. Different frequencies stimulate different locations along the membrane. The hair cells convert mechanical vibrations into electrical signals that travel along the auditory nerve to the brain. But here is what makes the ear truly remarkable. The cochlea itself has a shape, a logarithmic spiral. This is not random. This shape is the same spiral found in seashells, in galaxies, in the unfurling of ferns. The nautilus shell and the human cochlea share the same mathematics. Why? Because the logarithmic spiral is the optimal shape for responding to phenomena that change exponentially. Our hearing range spans from 20 Hz to 20,000 Hz, a 1,000-fold difference. A linear arrangement couldn't accommodate this range in a small space. A logarithmic spiral can fit an enormous range of frequencies into a compact structure. We are tuned to the universe's own geometry. The spiral also allows for something called cochlear amplification. Hair cells don't just passively respond to vibrations. They actively amplify incoming signals. This amplification is powered by the body's metabolism. It requires energy. In a sense, we are actively listening. We are not passively receiving sound like a microphone receives audio. We are energetically engaging with vibrations, boosting them, making them clearer. The ear is not a passive recorder. It is an active participant in the process of hearing. This has profound implications. It means that perception is not a neutral process. Our bodies are not transparent windows to reality. We literally shape and amplify the signals we receive. We construct what we hear. The geometry of the ear reveals something about how nature solves problems. The same principles that optimize a seashell for growth optimize a human ear for hearing. This suggests that there are universal mathematical solutions to universal problems. Evolution discovered the logarithmic spiral independently for many purposes. The universe seems to prefer certain shapes, certain proportions, certain mathematical relationships. The human ear is our direct connection to this mathematical order. From vibration to experience, the explanatory gap. Here is the hard part. Here is where science begins to stutter. We can trace sound through the entire chain from vibration to neural signal. We can map which brain regions activate when you hear different sounds. We can show in detail how the ear converts mechanical vibration into electrical impulses. We can show how auditory cortex processes different frequencies, and yet we cannot explain why all of this neural activity produces the conscious experience of sound. Why does hearing middle C feel like something? Not just any something, but specifically that something. The unique qualia of middle C. This gap between objective description and subjective experience is called the explanatory gap. And it is perhaps the deepest mystery in philosophy and philosophy. Neuroscience. Consider a thought experiment. Imagine we could map every neural connection in your brain down to the level of individual synapses. We could create a complete, perfect physical description of your auditory system. We could predict, based purely on physics, every neural firing pattern you would experience in response to any sound. And yet, we still could not predict what that sound will feel like. We could not predict that you will perceive redness of a trumpet's tone or warmth of a cello. We could predict the physics, but not the phenomenology. This is not a gap in current science that future discoveries will fill. Many philosophers argue it is a fundamental gap rooted in the nature of consciousness itself. There are two possibilities. Either consciousness is something over and above physical processes, something that emerges from matter but is not reducible to matter. Or consciousness is physical, but our current understanding of physics is incomplete. We're missing something fundamental about how physical systems produce subjective experience. Sound makes this problem vivid. Most philosophers don't think consciousness emerges from vision. They think sight is straightforwardly a matter of information processing. Light reflects off objects, enters the eye, creates neural patterns in visual cortex. The complexity is obvious but tractable. But sound feels different. A sound reaching your ear and creating a neural pattern seems to create something that the neural pattern itself does not contain, the felt quality of the sound. Where does that quality come from? Why should this particular pattern of neural firing feel like anything at all? These questions remain unanswered. They are the deepest questions consciousness studies can ask. And sound, more than any other sense, makes us confront them. The cocktail party problem: how attention shapes reality. Imagine you're at a crowded party. Dozens of conversations surround you. There is music, laughter, the clinking of glasses. Acoustically, it's cacophony. And yet, you can focus on one person's voice and follow their entire conversation. You filter out all the other sounds. You literally don't hear them, or rather, you hear them, but they don't register in consciousness. This everyday miracle is called the cocktail party effect, and it reveals something astonishing about how perception works. Your ears receive all the sounds at the party equally. All frequencies reach the cochlea. All sounds trigger neural responses, but only some of them reach conscious awareness. Your brain selectively attends to one voice while filtering others into the background. This is not passive reception. This is active construction of experience. What you consciously perceive is not all the information available to your ears. It is a filtered, selected subset of that information, determined by where you direct your attention. This has a philosophical implication of tremendous importance. Consciousness is not a camera passively recording reality. Consciousness is a spotlight actively selecting what to perceive, and what you perceive shapes your reality. If you don't attend to something, in a real sense, it doesn't exist for you. This is not mysticism. Brain imaging confirms it. Neural responses to unattended sounds are different from responses to attended sounds. Unattended sounds don't reach the same brain regions that generate conscious experience. They are processed by lower-level systems that don't create awareness. The unattended information is not lost, it's stored. It influences behavior unconsciously, but it doesn't become part of conscious experience. This means that reality, as you experience it, is literally constructed by your attention. You live not in the full, objective world, but in a world shaped by what you choose to attend to. And this choosing happens both consciously and unconsciously. Your interests, your fears, your habits all shape what you automatically attend to. Someone afraid of traffic will notice every car horn. Someone in love will notice their beloved's voice in a crowd. Someone trained in music will hear harmonies others miss. You are not perceiving a neutral world. You are perceiving a world your brain has constructed based on your values and expectations. The cocktail party effect is a window into a radical truth. Perception is participatory. You don't just receive reality, you create it through attention. And this creation happens moment by moment, largely outside conscious awareness. Infrasound and ultrasound, the hidden world. Below our conscious hearing threshold lies infrasound, vibrations below 20 Hz. These are frequencies we cannot consciously hear, and yet we can feel them. Infrasound creates a sensation in the body, a vibration in the chest, a sense of unease or awe. Concert venues sometimes use subwoofers that produce infrasound below the threshold of conscious hearing. Listeners don't hear these frequencies, but they report feeling moved, emotionally affected. Infrasound may be why people find waterfalls beautiful, or why large orchestras create such visceral emotional impact. Infrasound can also create discomfort. Some researchers have suggested that infrasound produced by wind turbines or traffic may cause health effects, not through hearing, but through physical vibration of bodily tissues. Above our hearing threshold lies ultrasound, frequencies above 20,000 Hz. Many animals navigate and communicate using ultrasound. Bats emit ultrasound at 100,000 Hz. Dolphins produce ultrasound for echolocation. Rodents use ultrasound to communicate. These animals live in an acoustic world completely invisible to humans. A bat flying through a room is creating a detailed acoustic map of the space using frequencies we cannot hear. The bat's brain interprets these echoes and perceives the world with resolution far exceeding human vision in complete darkness. The dolphin swimming in the ocean is communicating with others miles away using frequencies we cannot access. These creatures are conscious beings with rich perceptual worlds that exist alongside ours, but are largely inaccessible to us. What does it feel like to be a bat? To perceive the world through ultrasonic echolocation? What is the subjective experience of a dolphin sonar? We have no way to know. Their sensory worlds are as rich and complex as ours, but they access dimensions of reality we cannot. This reveals something humbling. Human consciousness is not the measure of all reality. We perceive a narrow slice of the vibrational spectrum. Beneath and above our hearing, an entire universe of sound and information exists, and we are almost completely blind to it. There are frequencies in this very room where you are listening, vibrations from electrical devices, from wireless networks, from the movement of air and objects. All of this carries information. All of it is real, and none of it reaches your conscious awareness. We swim in an ocean of vibration, aware of only a tiny fraction. This should make us humble about the nature of reality. What we perceive is not reality. It's our species' particular window onto reality. And that window is small. Synesthesia, when senses cross wires. Some people taste colors. Others see sounds as colors or shapes. When they hear a trumpet, they might see gold and orange. When they hear a cello, they see deep purple. This condition is called synesthesia, and it used to be dismissed as hallucination or psychiatric disorder. But neuroscience has revealed that synesthesia is a genuine neurological difference. Brain imaging shows that in people with synesthesia, sensory processing regions that should remain separate are interconnected. Stimulating one sense activates the other. Synesthesia is not a hallucination. The person is not imagining it. They are genuinely perceiving multiple sensations simultaneously. For many synesthetes, the condition is lifelong and unchanging. Every time they hear a particular sound, they see the same color. The color is not chosen consciously. It emerges automatically. What does synesthesia reveal? It reveals that the boundaries between senses are not fixed in nature. They are created by how our brains are wired. In most people, auditory information stays in auditory cortex, visual information in visual cortex, taste in gustatory cortex. But in synesthetes, these regions talk to each other. One person's cross-wiring is another person's unusual gift. Some synesthetes report that the condition helps their art, music, or creativity. They experience reality in a richer way than non-synesthetes. They have access to associations between senses that others must learn consciously. But synesthesia reveals something more profound. Our sensory categories are arbitrary. We divide reality into sight, sound, smell, taste, touch. But these divisions are not in the world. They are in our brains. In principle, any sensory input could be associated with any other sensory output. We could see sound and hear light and taste texture. The fact that we don't is a historical accident of how our brains evolved to be useful in our environment. Synesthesia shows us the fragility of our perceptual organization. It shows that conscious experience is constructed by brain architecture, not given directly by reality. What we perceive as fundamental categorical differences, sound versus sight, are actually just one possibility among many. The synesthete's brain is not broken. It's just wired differently. And in that difference, it reveals something true about all consciousness. Perception is a construction. The world doesn't come pre-divided into categories of sound and sight. Our brains create these categories, and those categories could be different. Why do we make music? Here is a puzzle that evolutionary biology cannot easily solve. Music serves no obvious survival purpose. It provides no calories, no protection, no reproductive advantage. A human who spent their life making music would, from a strict evolutionary standpoint, be less likely to survive and reproduce than a human who devoted all that time to hunting, gathering, and finding mates. Yet every human culture, without exception, makes music. This universality across cultures suggests that music taps into something fundamental about human nature. It is not a luxury. It is not a peripheral cultural decoration. It is central to what it means to be human. Why would we evolve the capacity for something that doesn't improve survival? One answer is that music is a byproduct. Perhaps the ability to hear music, to be moved by it, is a side effect of other capacities that do improve survival. Perhaps we evolved to recognize patterns, and music exploits pattern recognition. Perhaps we evolved to coordinate our movements in groups, and music facilitates this coordination. Perhaps we evolved language, and music is language's shadow, sharing similar neural machinery but serving no function of its own. But there's a problem with this byproduct theory. Music is too specific, too elaborate, too deeply integrated into human culture to be merely accidental. Every culture develops music independently. Children spontaneously sing and dance. Babies respond to rhythm before they understand language. Music seems woven into human development and society in ways that suggest it's not accidental. Another possibility is that music serves a social function. Making music together synchronizes brainwaves, creates group cohesion, and builds trust. Singing together bonds people. Dancing to the same rhythm creates a sense of unity. Perhaps music is an ancient technology for group bonding and coordination. This might explain why music is universal and why humans care so deeply about it. But this still doesn't fully answer the question: why should pattern and rhythm feel the way they do? Why should music be beautiful? Why should sound organized in certain ways move us emotionally? The deepest answer might be this: consciousness seeks meaning. Humans are not purely biological machines optimizing for survival. We are meaning-making creatures. We search for order, beauty, connection. Music gives us all of these. Music is organized sound that creates meaning. And perhaps the search for meaning is itself evolutionarily advantageous. Perhaps consciousness that seeks meaning, that creates beauty, that connects with others through art, is consciousness that survives and thrives. Music might not be a byproduct or even merely a social technology. Music might be fundamental to how consciousness works. The creation and appreciation of music might be how consciousness becomes aware of itself, how it finds meaning in an indifferent universe. The mathematics of beauty. When a musical interval sounds consonant, pleasing, harmonious, there is a mathematical reason. A perfect fifth, which sounds beautiful in every culture that has music, corresponds to a frequency ratio of 3:2. Two notes vibrating at frequencies in a 3:2 ratio will sound harmonious. A perfect fourth corresponds to a 4:3 ratio. An octave is a 2:1 ratio. The simplest ratios, small integer ratios, produce the most consonant intervals. More complex ratios produce dissonant, unstable sounds that our ears reject. This discovery, made by Pythagoras 25 centuries ago, suggests that beauty is not subjective. Beauty has a mathematical basis. Consonance correlates with mathematical simplicity. But here is where philosophy enters. Is beauty discovered or invented? Does mathematical simplicity cause beauty? Or does mathematical simplicity merely describe beauty that arises from human preference? The question matters because it tells us something about the nature of both mathematics and consciousness. If beauty is discovered, if simple ratios are beautiful in themselves, independent of human minds, then mathematics might be the deepest layer of reality. Beauty would be woven into the fabric of existence. Consciousness would be discovering pre-existing mathematical truths. But if beauty is invented, If humans simply find simple ratios pleasing because of how our ears and brains evolved, then beauty is not in the world. It is in us. Mathematics would be a human tool for describing patterns we find, not the fundamental reality itself. The evidence leans toward discovery. Simple ratios are consonant across cultures. Babies show preference for consonant over dissonant intervals before they've heard music. Other animals respond differently to consonant and dissonant sounds. This suggests that consonance and dissonance tap into something deep in biological organization, not merely cultural preference. But perhaps this doesn't settle the philosophical question. Perhaps biological brains, shaped by evolution, are simply tuned to find beauty in what helps us survive. Perhaps the consonance of simple ratios is beautiful because harmony was important for group coordination in our evolutionary past. Yet this still leaves a mystery. Why should mathematical simplicity feel beautiful? Why should our brains respond to elegant ratios with pleasure? The answer might be that consciousness is fundamentally mathematical. If the brain is a physical system, and if physical systems operate on mathematical principles, then perhaps consciousness itself is mathematical. In that case, consciousness naturally resonates with mathematical elegance. We find simple ratios beautiful because our own consciousness is built on mathematical principles. We recognize in music the mathematical structure of our own minds. The problem of musical emotion. Play a major chord, and most people hear something bright, optimistic, uplifting. Play a minor chord, and most people hear something sad, melancholic, introspective. This emotional association seems universal and immediate, but there is nothing inherently sad about a lower frequency or an altered harmonic structure. The frequency itself carries no emotion. A minor chord is just vibrations at certain frequencies. How does physics become feeling? Some theorists suggest that minor keys are culturally associated with sadness through learning. We've heard minor music in sad contexts, so we learn to associate minor with sadness. But this doesn't explain why the association works across cultures where musical traditions are completely different. A minor scale in Indonesian gamelan music is not the same as a minor scale in Western classical music, yet both are heard as melancholic. Others suggest that musical emotion is metaphorical. We call minor chords sad, the way we call abstract ideas bright. We project human emotions onto music through metaphor. But again, this doesn't explain why these particular metaphors work universally. Why do we call low frequencies dark rather than clear? Why do we call major chords happy rather than simple? The deepest theory is that music taps into universal features of how emotions are expressed in human vocalization. When humans feel sad, their voices drop in pitch and slow in tempo. When humans feel happy, their voices rise and quicken. Minor keys with lower pitches and slower tempos mimic the vocal patterns of sadness. Major keys mimic the vocal patterns of joy. In this view, music emotionally moves us because it speaks in the same acoustic language as human emotion itself. We recognize emotional states through music, the way we recognize them in voices. But this still raises a mystery. Why should these acoustic patterns mean anything? Why should low pitch and slow tempo feel sad? The answer might be deeply embodied. Perhaps emotional meaning is not purely cognitive. Perhaps when we hear low-pitched, slow music, our bodies mimic it, our breathing slows, our heart rate declines. We literally enter a state similar to sadness. The emotion emerges not from intellectual understanding, but from embodied synchronization with the music. We don't just hear music, we synchronize our bodies with it. And when our bodies are in a state similar to sadness, we feel sad. The emotion is real, but it arises from the body's resonance with the music, not from the music carrying emotion as cargo. The silence between notes. In Western classical music, silence has a name: the rest. A rest is a musical notation indicating that an instrument should be silent for a specified duration. Silence is not the absence of music. Silence is part of music. A symphony without silences would be cacophony. The spaces between notes give meaning to the notes. A note matters because it is followed by silence, which makes the next note stand out. Melody depends on the spacing of notes. Rhythm depends on the spacing of sounds. Without silence, all sounds would blur together into one continuous noise. The conductor's baton moves through silent moments just as it moves through sounding moments. Silence is performed. It is as part of the musical work as the notes themselves. The greatest expression of this principle is John Cage's piece 433, composed in 1952. The piece consists of 3 movements of silence. A pianist sits at a piano and does nothing for 4 minutes and 33 seconds. No notes are played. No sounds are produced intentionally. And yet, the piece is performed in concert halls to audiences who sit in silence, listening. What are they hearing? They hear the ambient sounds of the concert hall. The hum of the air conditioning, the shuffle of people in seats, the distant traffic outside, someone coughing, the audience member's own heartbeat. Cage's insight was that silence is not empty. Silence is full. When we stop producing intentional sound, we become aware of the sounds we normally ignore. Cage was not creating silence. He was creating an opportunity to hear the silence that is always present. The piece forces us to confront a philosophical truth. There is no such thing as absolute silence. There is always sound, and sound always carries meaning. The ambient noise of a concert hall is not random. It is the sound of human presence, of bodies in space, of the building itself responding to wind and traffic and vibrations from the earth. When we stop performing and listen, we hear that the world is always speaking. The silence between notes is pregnant with potential. It is the space where the listener completes the music, where imagination fills the gap. Different listeners, hearing the same notes and silences, imagine different completions. The silence is where the listener becomes a co-creator of the music. This might be the deepest truth about music. Music is not the notes. Music is the relationship between notes and silences, between sound and listener, between performer and audience. Remove the listener, and music becomes merely vibrations. The listener completes the work. Silence is the space where this completion happens. Universal music versus cultural difference. All lullabies share something in common. When mothers around the world sing to their infants, the music is higher in pitch, slower in tempo, and more repetitive than speech. Lullabies across cultures, from Australian Aboriginal to Japanese to Navajo to Irish, share these acoustic properties. Something universal in human biology makes high-pitched, slow, repetitive sound soothing to infants. This suggests that music taps into something innate in human development. Yet within this universal capacity for music exists tremendous cultural diversity. The harmonic systems of Western classical music, with equal temperament, tuning, and functional harmony, are not universal. Many non-Western traditions use tuning systems that Westerners perceive as out of tune. The rhythmic structures of West African music, with polyrhythmic complexity, are radically different from the simple meters of European music. The vocal techniques of Mongolian throat singing are unimaginable in Western classical tradition. If music is universal, how can musical traditions be so different? The answer is that humans have a universal capacity for music, the ability to hear and respond to organized sound. But what counts as beautiful or meaningful music is culturally learned. An infant might find all music soothing, but as children grow, their culture shapes what music they prefer. By adulthood, people find their own musical tradition beautiful and unfamiliar traditions strange or unpleasant. cultural exposure shapes musical preference. But there is something deeper here. Different musical traditions solve the same problem in different ways. Every musical tradition creates order from chaos. It takes the infinite space of possible sounds and organizes them according to rules. Every tradition uses some version of scale, a set of preferred pitches. Every tradition uses rhythm and repetition. Every tradition creates patterns that the human mind finds satisfying. The differences lie in which patterns are chosen, which intervals are preferred, which rhythms are considered beautiful. But the fundamental principle is universal. Humans organize sound according to rules that create meaning and order. This suggests something about consciousness. Consciousness seeks patterns. It seeks organization. It seeks to find order in the world. Music is one way consciousness expresses this fundamental drive. Different cultures find different patterns beautiful, but all cultures recognize beauty in pattern. The universality of music reflects something universal about how minds work. All humans seek meaning through organization of experience. Music is sound organized to create meaning. That humans everywhere make music reveals that the search for meaning through organization is not peripheral to consciousness. It is central. It is perhaps what consciousness fundamentally is. Listening as attention and knowledge. The word attention comes from the Latin attendere, which means to turn toward. When you attend to something, you turn your mind toward it. Listening is perhaps the purest form of attention. When you listen, you must quiet your own thoughts and open yourself to receive what comes from outside. This act of opening, this willingness to be changed by what you hear, is fundamental to all learning. Science begins with listening. A researcher listens to what an experiment reveals. They form a hypothesis and then listen carefully to whether reality confirms or contradicts that hypothesis. The scientist who refuses to listen to contradictory evidence is not doing science. Philosophy begins with listening to questions. A philosopher listens to the deepest questions about existence and refuses the answers. They listen to the silence within the question, the gap between what we think we know and what we truly understand. Psychotherapy is, at its foundation, the practice of listening. A therapist listens to what a client cannot say. Healing begins when someone feels truly heard, when their inner world is recognized and received by another consciousness. In all these domains, listening is not passive. It is profoundly active. Listening requires effort, discipline, openness. It requires suspending judgment long enough to understand what is being said. It requires imagination, the ability to understand another person's perspective as if it were your own. Listening is the foundation of empathy. When you listen to someone deeply, you are recognizing them as a conscious being equal to yourself. You are saying, through your attention, that their inner world matters, that their truth is worth receiving. This is why listening can be a radical act in a noisy world. In modern life, we are bombarded with sound. Advertisement, music, voices, alerts, all competing for our attention. True listening becomes rare. The capacity to attend to one thing deeply, to be quiet enough to hear what is subtle, to be patient enough to wait for meaning to emerge, these become increasingly valuable, and they become increasingly difficult to practice. But perhaps this is what the study of sound and philosophy teaches us, that listening is not a luxury. It is foundational. Without the capacity to listen, we cannot learn. Without listening, we cannot truly know other people. Without listening, we cannot understand ourselves. The quieting of the self required for listening is perhaps the most important skill consciousness can develop. It is also perhaps the most ancient skill, the one humans practiced before language, when the first conscious beings listened to the sounds of their environment and learned what the world contained. the Neuroscience of Attention. Brain imaging has revealed something remarkable. When you attend to a sound, your brain doesn't just passively receive the sensory information, your brain actively amplifies it. The neural response to an attended sound is dramatically larger than the response to an unattended sound, even though both sounds are physically identical. Attention modulates perception at the most basic levels. In the auditory cortex, neurons responding to an attended sound fire more strongly and more consistently. But this modulation begins even earlier, in the cochlea itself. The hair cells in the cochlea that respond to attended frequencies show enhanced sensitivity. Your attention literally changes how your ear processes sound at the biological level. This means that perception is not a passive process where sensory data flows into the brain like water flowing downhill. Perception is an active process where the brain reaches out and selects information from the environment. The brain is constantly generating predictions about what it expects to encounter. When the sensory input matches the prediction, the brain confirms the expectation. When the input violates the prediction, when something unexpected happens, the brain sends a signal of surprise. Novelty and violation of expectation are what capture attention. A repeated, expected sound fades into the background. An unexpected sound suddenly becomes prominent. This is why parents can sleep through traffic noise, but wake immediately at their baby's cry. The traffic is expected. The cry is surprising. The brain has learned to filter the expected and amplify the unexpected. But here is what makes this profound. This means you are not perceiving reality as it is. You are perceiving reality as your brain predicts it should be. Your brain is constantly making a model of the world, anticipating what will happen next, and comparing those predictions to sensory input. Conscious experience is the result of this predictive process. When you perceive a friend's face, your brain is not passively receiving a visual image. Your brain is predicting what the face should look like based on memory and experience. And when the sensory input matches that prediction, you perceive the face. If the prediction doesn't match the input, if your friend looks different than expected, you consciously notice the discrepancy. Consciousness is fundamentally about the matching and mismatching of prediction and input. Sound reveals this principle vividly because sound is temporal. Vision is spatial. You can look at a scene and take it all in at once. But sound unfolds in time. You must predict what the next note will be, what the next word will be. When those predictions are confirmed, you experience fluency. When they are violated, you experience surprise. Music plays with this predictive system constantly. A good melody violates your predictions just enough to be interesting, but not so much as to be incomprehensible. Jazz improvisation is the art of violating predictions while maintaining enough continuity for the brain to understand. This reveals something about consciousness. It is fundamentally predictive. And attention is the mechanism by which consciousness selects which predictions matter most. Sound and memory. Why music unlocks the past. A song can transport you instantly to another time. You hear a few notes, and suddenly you're back in high school, in the car with friends, in love with someone you haven't thought about in years. The memory returns complete with emotional force. Not just the memory of the events, but the feeling of being that person in that time. Why does music have this power? Why does sound access memory differently than other senses? One reason is that music is deeply connected to the emotional centers of the brain. Sound triggers activity in the limbic system, the region involved in emotion and memory formation. A visual image might trigger memory through association, but music often seems to bypass the rational mind and activate memory and emotion directly. Another reason is temporal continuity. Music, like memory, unfolds in time. When you listen to a song, your brain is making predictions about what comes next, just as memory is reconstructing a sequence of past events. The temporal structure of music maps onto the temporal structure of autobiographical memory. Songs we heard at significant moments in our lives become intertwined with those memories. The song becomes a time capsule, and hearing it again opens the capsule. But there's something deeper. Music seems to access episodic memory, the memory of specific events and moments, more directly than other stimuli. You might forget the words a friend said, but you remember the song playing when they said it. You might forget what you did on a particular day, but you remember the music from that day. This suggests that music is encoded in memory differently than language. Words are encoded as semantic information, the meaning. But music seems to be encoded more holistically, including the emotional and contextual information surrounding the moment. Neuroscientist Oliver Sacks documented a patient with severe amnesia who could not form new memories or recall recent events, but who retained the ability to play piano beautifully. His procedural memory, the embodied knowledge of how to perform a skill, was intact, even though his declarative memory was shattered. This reveals that memory is not one unified system. Music seems to access memory systems that are more resistant to decay and more resilient in conditions like dementia and amnesia. Patients with advanced Alzheimer's who cannot recognize their own children sometimes respond to familiar songs. The music reaches some deeper level of consciousness that language cannot reach. This might be because music is ancient. Humans have made music for at least 40,000 years, perhaps much longer. Language, as we know it, is much younger. The neural systems that process music might be more fundamental, more deeply wired into human consciousness than the systems for language. Memory, too, might have musical roots. Perhaps autobiographical memory is structured like music, a series of moments connected by emotional continuity, not just logical sequence. Listening to music that was present at significant moments in our lives reactivates not just the memory, but the emotional state, the embodied experience of that moment. Neural synchronization, the biology of togetherness. When people listen to the same music together, something remarkable happens in their brains. Their neural activity begins to synchronize. The brainwaves of different listeners become more similar to each other. This phenomenon is called neural synchronization or brain-to-brain coupling. What makes it profound is that it happens without any conscious effort. The listeners don't need to communicate or coordinate. Simply by listening together to the same sound, their brains begin to vibrate in harmony. But it goes even deeper. The synchronization between listeners' brains correlates with their subjective sense of connection. When their neural activity is more tightly synchronized, they report feeling more connected to each other. They experience a sense of unity, of moving together, of being part of a group. Rhythm is particularly powerful at creating synchronization. When multiple people hear the same rhythm, their bodies want to move together. From ancient drumming circles to modern concerts to religious chanting, rhythm creates physical and neural synchronization. Children naturally want to dance to music. This is not learned. This is an innate response to rhythm that seems wired into the human nervous system. The evolutionary advantage is obvious. Synchronized groups are more cohesive, more capable of coordinated action, more likely to survive and reproduce. But the philosophical significance is deeper. Neural synchronization reveals that consciousness is not purely individual. It's not locked within each person's skull. Consciousness can extend between people through the medium of shared sound. When your brainwaves synchronize with another person's, in what sense are your consciousnesses separate? The boundaries between individual minds become blurred. You are experiencing a sense of unity that is not metaphorical. It is neurologically real. Your brain is literally coordinating with another brain. This challenges our usual picture of consciousness as something that happens inside an individual mind. Perhaps consciousness is more fundamentally relational. Perhaps individual consciousness is just a local manifestation of consciousness that extends through relationships and connections. When people synchronize through music, they access a larger consciousness, the consciousness of the group. This has practical implications. It explains why people are drawn to music and why music is universal. Music is a technology for creating connection and synchronization. In groups synchronized by music, people trust each other more, work together more effectively, and feel less alone. Music doesn't just entertain. Music fundamentally alters the structure of consciousness, making it more collective, more shared, more unified. This might be why humans need music as much as they need food or sleep. Music is how consciousness expands beyond the individual and touches the consciousness of others. The auditory cortex and prediction. The brain doesn't just receive sound passively. The brain is constantly predicting what sounds will come next. The auditory cortex generates predictions based on patterns it has learned. When you listen to speech, your brain predicts which words are likely to come next, based on context. When you listen to music, your brain predicts which notes are likely to come next, based on melody and harmony patterns. These predictions happen largely unconsciously. You don't deliberately think through the probabilities. Your brain does this automatically, at the level of neural firing. When the predicted sound arrives, the brain's response is minimal. It confirms the prediction quietly. But when an unexpected sound arrives, when your prediction is violated, the brain sends a strong signal. This signal of prediction error is what creates the sense of surprise. It's what makes you notice something unexpected. Consciousness, from this perspective, is not about receiving information. Consciousness is about the difference between prediction and reality. The brain is constantly generating a model of what should be happening. Conscious experience emerges from the moment-to-moment comparison between that model and actual sensory input. This has radical implications. It means that what you consciously perceive is not the world as it is. It's the difference between what your brain expects and what actually happens. If your predictions are perfect, if the world matches your expectations exactly, you might perceive almost nothing consciously. You would be operating on autopilot. Conscious experience requires surprise, requires violation of expectation, requires the world to reveal itself as different from your predictions. This explains why novel situations feel vivid and memorable, while routine situations fade into the background. It explains why music that is perfectly predictable can be boring, while music that is surprising can be engaging. It explains why falling in love is so intense. You cannot predict another person perfectly, so you are constantly experiencing surprise, constantly conscious. The auditory system is particularly good at revealing this principle because sound unfolds in time. You cannot perceive a whole sound at once. You must build it moment by moment, predicting the future and comparing that prediction to what arrives. The entire experience of sound is the experience of prediction being confirmed or violated. This suggests something about the nature of consciousness itself. Consciousness might be fundamentally about the difference between what was expected and what actually occurs. Consciousness might be the way the universe becomes aware of its own surprising character. When something happens that the universe didn't predict about itself, consciousness emerges as the registration of that surprise. The voice as unique identity. Your voice is more distinctive than your fingerprint. No two human voices are identical. Even identical twins with identical DNA have different voices. The voice carries information about your physical structure, the size and shape of your vocal cords, your mouth, your resonating chambers. It carries information about your gender, your age, your health. But it also carries information about something less tangible, your identity, your personality, your emotional state. Forensic scientists can identify individuals by analyzing voice patterns. Machines trained on thousands of voice samples can identify a specific person's voice with greater than 99% accuracy. The voice is that distinctive. But more remarkably, we recognize each other's voices not through conscious analysis, but through immediate, intuitive recognition. You know your mother's voice within a single word. You recognize a friend's voice in a crowd. This immediate recognition happens before any conscious thought. The brain recognizes the voice pattern and activates the memory of the person associated with that voice. The voice is so intimately connected to personal identity that losing your voice feels like losing yourself. People who lose the ability to speak due to stroke or disease often report a profound sense of disconnection from their own identity. They are still the same person neurologically, but without the voice, something essential seems missing. The converse is also true. Someone whose physical body is severely damaged might maintain their sense of self if their voice remains. As long as they can speak, they are still themselves. This reveals that identity is not purely physical. Identity is something that must be expressed and recognized. The voice is the primary vehicle for expressing identity. Through voice, we communicate not just information, but ourselves. When you speak, you are giving yourself away. You are externalizing your interiority, making your inner world audible to others. The voice carries the imprint of consciousness. Neuroscience reveals that areas of the brain involved in self-awareness show different activation patterns when people speak than when they listen to others. Speaking is a form of self-expression that involves the deepest levels of self-awareness. Listening to your own voice can be disorienting. You sound different to yourself than to others because you hear the vibrations through your own bone structure. When you hear a recording of your voice, you might not recognize it as yourself. This is because the recording carries the sound as others hear it, not as you hear it from inside your own body. But others recognize it immediately as you. The voice, then, is a bridge between interior and exterior, between self and world. It is how your internal subjectivity becomes a physical phenomenon that others can perceive. Without the voice, the self would remain entirely private. The voice is what makes the self knowable to others. The evolution of language, sound becomes meaning. Humans are not the only animals that vocalize. Birds sing. Whales sing. Primates make elaborate vocalizations. Yet, human language is different. It has grammar. It has unbounded generativity, the ability to create infinite new sentences from a finite set of words and rules. It has abstraction, the ability to speak about things that are not present, things that never existed, things that are purely imaginary. Language is uniquely human. But language didn't appear out of nowhere. It evolved from simpler systems of vocalization. The question of how language evolved has long puzzled scientists. What selective pressure would favor the evolution of grammar? What advantage does syntax give? Some theorists suggest that language evolved from song. Perhaps music came first, with its capacity for complex rhythmic and melodic patterns. Perhaps grammar arose as humans developed increasingly sophisticated ways to organize and communicate information. The brain regions involved in language processing overlap significantly with regions involved in music processing. Broca's area, crucial for language production, is also involved in music performance. The rhythmic patterns of language, the stressed and unstressed syllables, the rise and fall of pitch, are musical. Language might be music that has been shaped by the need to communicate specific, precise meanings. What language adds to vocalization is the possibility of abstraction and recursion. A bird's song is fixed. A whale's song might vary slightly, but it follows predictable patterns. Language allows you to speak about the past, the future, the hypothetical, the impossible. You can say, If the weather is clear tomorrow, I will go to the mountain. You can speak about abstract concepts like justice or love. You can quote others, speak about what others said, about what still others said. Infinite levels of recursion. This capacity for abstraction seems to be the key difference. Language gives consciousness the ability to represent the world in new ways. Instead of being bound to immediate perception, the mind can manipulate symbols. It can imagine futures that don't exist. It can explore hypotheticals. It can accumulate knowledge across generations, passing it through words. The evolution of language created an explosion of human potential, but it might have come at a cost. As language became more sophisticated, humans might have become less connected to immediate sensory experience. Language creates categories and abstractions that can distance us from raw reality. A philosopher might speak about love without feeling love. A poet uses words to evoke feeling. The relationship between language and lived experience is complex and sometimes contradictory. What's clear is that language transformed consciousness. It gave humans the ability to think in ways other animals cannot. It gave humans the ability to share those thoughts across generations. Language is sound elevated to meaning-making. And the evolution of language shows how consciousness increasingly uses symbols and abstraction to understand reality. The power of spoken words, magical thinking, or real effect. In many spiritual traditions, words are understood as creative. In the biblical Genesis, creation happens through speech. God said, "Let there be light," and there was light. In Hindu philosophy, the sacred sound Om is understood as the vibration from which reality emanates. In Islamic tradition, the Quran is understood as the speech of God. The word itself carries transformative power. This understanding of words as creative seems magical. It seems to contradict scientific materialism, which holds that words are merely descriptions of reality, not creators of it. And yet, neuroscience reveals that words literally shape the physical structure of the brain. When you learn a new language, you grow new neural connections. When you practice speaking a new word, you strengthen the neural pathways associated with that word. The word changes your brain. Words also shape your emotional state. Hearing certain words activates regions of the brain associated with emotion and memory. The words your parents spoke to you as a child shaped your sense of yourself, your self-worth, your expectations of love. Abusive words literally stress the body, activating the sympathetic nervous system. Loving words calm the nervous system. Words have physiological effects. This is not metaphor. When you speak a cruel word, you change the neural chemistry of the person who hears it. When you speak a kind word, you trigger the release of oxytocin and serotonin in their brain. Words shape reality through their effects on consciousness and on the body. But there's something more. Words shape how you perceive reality. The language you speak shapes how you categorize the world. Different languages have different color terms. A language with fewer color words makes distinctions between colors less precisely. Speakers of that language show different color perception abilities than speakers of languages with more color words. Language doesn't just describe reality. Language shapes what you notice in reality. Words create categories that shape perception. Once a word exists for something, you begin to notice that thing everywhere. Before you learned the word phenology, you might not have noticed the patterns of seasonal change. Now, with the word, you perceive these patterns. Language shapes consciousness by shaping what you notice. The power of spoken words, then, is not magical in a supernatural sense. It is magical in the sense that words have real effects on consciousness, on the body, on the brain, on the world. The ancient wisdom traditions understood this. They understood that words are not mere descriptions. Words are forces. Words create and transform. Science is beginning to catch up with this ancient insight. Prosody, the music underneath words. When you speak, you don't just produce words. You produce them with rhythm, intonation, and emotional tone. These features, rhythm, intonation, stress patterns, pitch contours, are called prosody. Prosody is the music of speech, and it carries as much information as the words themselves. A single sentence can mean completely different things depending on its prosody. "You're going to the party" spoken with rising intonation and excitement means one thing. The same words spoken with falling intonation and resignation means something different. The prosody conveys emotion, intention, sincerity. When prosody contradicts the words, when someone says, "I'm fine," with a tone of voice that clearly indicates distress, we trust the prosody over the words. We assume the person is not actually fine. This reveals that prosody is more fundamental to communication than words. Prosody carries emotional and intentional information that words cannot. Infants learn to understand the emotional content of speech before they understand the meaning of words. A baby hears the prosody of their caregiver's voice and knows whether that person is angry, sad, loving, or playful. The meaning comes from prosody, not from words. Different languages have different prosodic systems. Some languages use pitch changes to distinguish word meanings. These are called tonal languages. In Mandarin Chinese, the word ma, spoken with rising pitch, means mother. With falling pitch means hemp. With rising falling pitch means horse. The pitch contour, the prosody, determines the meaning. Other languages use prosody for emotional expression rather than meaning. But all languages have prosody. This suggests that prosody is more fundamental than language itself. Music and speech share the same deep structure. They are both organized sound with rhythm and pitch. In fact, the distinction between music and language might not be as fundamental as we think. When you listen to a foreign language you don't understand, it sounds almost musical. The sounds have rhythm and contour, but you can't extract meaning from the words. Yet you can perceive the speaker's emotional state through prosody. A crying voice sounds different from an angry voice in any language. The prosody reveals the emotional truth beneath the words. This has implications for how we understand communication and consciousness. It suggests that consciousness is conveyed through sound at a pre-linguistic level. Your emotional state is encoded in your voice, in the rhythm, the stress patterns, the intonation. Before you speak a single word, your voice has already revealed who you are and how you feel. Speech adds semantic meaning to this basic emotional communication. But the emotional substrate, the prosody, remains fundamental. In music, we experience this directly. Instrumental music, without words, conveys emotion through prosody alone. A melody in a minor key with slow tempo and soft dynamics conveys sadness, not through meaning, but through the sound itself. Music and speech are fundamentally similar in this way. They both use prosody to convey the emotional truth of consciousness. The unspoken, what silence in conversation reveals. In psychotherapy, silence is considered data. What a person doesn't say is often more revealing than what they do say. A patient might talk endlessly about their childhood without revealing the deepest wounds. But in a moment of silence, when words fail and emotion becomes too large for language, something authentic emerges. The therapist learns to listen to the silence, to notice the places where speech breaks down. These places often mark the limits of what consciousness can articulate. There are experiences too large, or too painful, or too strange to be captured by words. Trauma often manifests as a kind of silence, an inability to speak about what happened. The event is too overwhelming to be integrated into the narrative self. It remains unspoken, locked in the body, affecting the person's behavior and emotions without ever being given words. Part of healing involves bringing language to the unspoken trauma, finding words for what happened. This act of putting experience into words seems to help integrate the experience, to make it part of the coherent narrative of the self. Silence also marks the limits of individual consciousness. In a conversation between two people, silence happens when both individuals reach the edge of what they can understand or express. The silence becomes shared. It becomes a space where connection happens without words. Two people sitting together in silence can feel profoundly connected, even though no information is being exchanged. The connection is being experienced directly, body to body, presence to presence, without the mediation of language. In music and poetry, silence is an essential tool. A pause in speech can be more powerful than words. A beat of silence in music can create tension that makes the next note more powerful. The artist uses silence deliberately to create meaning. The painter uses empty space in a painting. The poet uses line breaks and stanzas. These silences, these empty spaces, give meaning to the full spaces. They create rhythm and emphasis. Without silence, everything would be noise. Silence gives form to sound just as it gives form to speech. The unspoken also includes everything that is unconscious. There are vast regions of your consciousness that have no access to language. Your body knows things that your mind cannot articulate. Your emotional life contains nuances that language flattens. Your intuitions know truths that cannot be reasoned. These aspects of consciousness, the emotional, the embodied, the intuitive, are always present but often unspoken. They influence behavior and experience without being consciously articulated. Psychoanalysis recognized this early. Freud understood that the unconscious mind has intentions and knowledge that the speaking self doesn't have access to. The unconscious expresses itself through dreams, through slips of the tongue, through silences and hesitations. Modern neuroscience confirms this. The vast majority of the brain's processing happens outside consciousness. The conscious mind is the tip of an iceberg. Most of what makes you who you are, your values, your fears, your automatic reactions, operates silently, below the threshold of articulation. The unspoken is not empty or insignificant. The unspoken contains the deepest truth. The quantum vacuum is empty space actually empty? Most people think of empty space as nothing. A vacuum is the absence of matter, the absence of substance. But quantum physics has revealed that empty space is far from empty. At the quantum level, empty space seethes with activity. Virtual particles continuously appear and disappear. These are not particles that exist in the normal sense. They appear for infinitesimally brief moments, borrowing energy from the quantum vacuum, and then annihilate. Pair after pair of particles and antiparticles are constantly being created and destroyed. This quantum foam is not theoretical. Its effects are measurable. The Casimir effect is a physical phenomenon in which two metal plates placed very close together experience a small but measurable attractive force. This force arises because the quantum vacuum has slightly different densities in different regions. The space between the plates has fewer virtual particles than the space outside, creating an imbalance of force. Empty space, measured precisely, is not empty. This raises a profound philosophical question: what is nothingness? Is absolute nothingness possible? The quantum vacuum suggests that complete emptiness is not possible. Even at the deepest level of reality, even in the absence of particles and fields, something remains. There is the quantum vacuum itself, the substrate from which particles emerge and into which they disappear. The vacuum is not nothing. It is something with properties and dynamics. Silence, then, might be understood analogously. We say silence is the absence of sound. But just as the quantum vacuum is not truly empty, silence might not be truly empty. Silence might be pregnant with potential. In silence, sound is not present, yet the possibility of sound remains. The ear in silence is still listening. The mind in silence is still thinking, still processing. Silence is not the absence of activity. Silence is not the absence of activity. It is the absence of audible activity. But beneath the surface of silence, vast amounts of neural activity continue. The brain in silence is still generating predictions, still searching for patterns, still making meaning. This reframes how we understand emptiness. In philosophy, the concept of the void or emptiness appears in many traditions. The Tao Te Ching speaks of emptiness as the space that makes the cup useful. A cup is valuable not because of the material, but because of the space it contains. The emptiness is what allows the cup to hold things. Architecture uses emptiness deliberately. A room is valuable because of the space it contains. The emptiness is what allows activity and life to unfold. Similarly, consciousness might be understood through emptiness. The empty space in consciousness, the moments of not thinking, the gaps between thoughts, might be as important as the thoughts themselves. In meditation, practitioners often aim for what is called no mind or empty mind. But this emptiness is not truly empty. It is a state where the constant chatter of thought quiets, but consciousness itself remains. It is emptiness full of presence. The quantum vacuum teaches us that true emptiness is impossible. Even the void contains something. Perhaps this is what contemplatives have understood for millennia. True emptiness, true silence, true void. These are not actual nothingness. They are fullness that appears as emptiness to the limited perception of consciousness. The threshold of hearing, where sound becomes imperceptible. Sound exists on a threshold. Below the threshold of human hearing, sound waves exist, but we don't perceive them as sound. Above the threshold, we lose the ability to detect the vibrations. But the question is, what makes something cross the threshold from imperceptible to perceptible? The answer involves two things: the absolute intensity of the sound and the frequency at which it occurs. The threshold of hearing is not the same for all frequencies. Humans hear best at frequencies around 1000 to 4000 Hz. At this frequency range, we can detect extremely faint sounds. We can hear a sound with intensity as low as 20 micropascals of pressure. This is an astoundingly small amount of physical force. It's roughly equivalent to the sound of a pin dropping from an inch height. But at frequencies below 20 Hz or above 20,000 Hz, we need much more intense sounds to perceive them. The threshold of hearing varies dramatically across the frequency spectrum. This variation reveals something about how our ears and brains evolved. We evolved the best hearing at frequencies where the human voice falls. We evolved to hear human communication with exceptional sensitivity. But we are comparatively deaf to very low and very high frequencies. Yet just because we can't hear these frequencies doesn't mean they don't exist. Below the threshold of hearing, the entire world of infrasound continues. The Earth vibrates at infrasound frequencies during earthquakes. The ocean vibrates at infrasound frequencies. The wind creates infrasound. Animals communicate using infrasound. All of this sound exists continuously below the threshold of our hearing. Above the threshold, ultrasound fills the environment. Bats fill the air with ultrasound. Insects communicate using ultrasound. Machinery creates ultrasound. All of this sound exists, but we are deaf to it. This reveals something about perception. What we perceive as the world is not the world as it is. It is the world filtered through the limitations of our sensory organs. The real world, the complete world, is far larger than what we perceive. We live in a bubble of perception, and outside that bubble, vast regions of sound and information exist unheard. But there's something more subtle here. The threshold of hearing is not absolute. It varies between individuals. Some people can hear higher frequencies than others. Children typically hear better at high frequencies than adults. As you age, you lose sensitivity to ultrasound. Some people with unusual neurological conditions hear better in frequency ranges where others are deaf. This individual variation suggests that the threshold of hearing is not a hard boundary imposed by physics. It's a boundary created by the biological structure of the ear. And biology is plastic. It can vary. The threshold of perception, then, is something that can change. As we age or develop hearing loss, our threshold shifts. New technologies like hearing aids can alter the threshold, allowing people to hear frequencies they couldn't hear before. This opens a philosophical question. If perception can be extended beyond our natural limits, does that change what we are? If we could somehow extend our hearing into infrasound and ultrasound, would we become fundamentally different kinds of beings? Would we perceive a different world? The answer seems to be yes. The sensory world we perceive would expand. New information about reality would become available. We would be transformed. Tinnitus and the sound of nothing. Some people experience a constant sound that no one else can hear. A ringing, a buzzing, a roaring, a sound that is always present. This phenomenon is called tinnitus. Millions of people experience tinnitus. It can be extremely distressing. Imagine hearing a sound constantly, day and night, that you cannot escape, that no one else hears, that doesn't come from any external source. Tinnitus was long thought to be a hearing problem. Perhaps the ear was producing a phantom sound. But modern neuroscience has revealed something different. Tinnitus is produced in the brain. In some cases, when the ear loses sensitivity to certain frequencies, the auditory cortex becomes hyperactive at those frequencies. The neurons that normally receive input from those frequencies begin firing spontaneously. The brain interprets these spontaneous firings as sound. In other cases, tinnitus arises from heightened attention to normal background sounds. The brain gets stuck in a loop of attending to these sounds, amplifying them, making them seem louder than they are. Tinnitus reveals something remarkable about how sound works. Sound is not something transmitted from the ear to the brain. Sound is something the brain constructs. The brain uses information from the ear, but it actively generates the perception of sound. If the ear sends no input, if there is silence, the brain can still produce the perception of sound. Tinnitus is the sound of nothing, yet it is experienced as something. For people with tinnitus, silence does not exist. They live in constant sound generated by their own brains. This is profoundly disorienting. It reveals that silence is not a physical state. Silence is a perceptual state. It depends on the absence of both external sound and the brain's generation of phantom sound. Tinnitus is present in roughly 15 to 20% of the population at any given time. In most cases, people adapt to it and stop noticing it. But in some cases, it becomes unbearable. The person cannot ignore it because the brain, in trying to attend to it and understand it, amplifies it further. The struggle to not hear the sound makes the sound louder. Neuroscientists and therapists have discovered that acceptance helps. When people stop struggling against the tinnitus and accept it as background, it often diminishes. The paradox is that the more you try to eliminate the sound, the more prominent it becomes. But when you accept its presence and stop attending to it so intently, it recedes. This reveals something about consciousness. What we attend to becomes prominent in experience. What we accept and stop fighting becomes manageable. Tinnitus teaches us that consciousness is creative. The brain generates experience. And experience can be modified by changing attention and acceptance. Tinnitus also reveals the difference between sound and silence. Sound is not purely physical. It is partly physical vibrations in the ear and partly mental, the brain's interpretation of those vibrations. Silence is the absence of attended to sound. But as tinnitus shows, even in the absence of external sound, the brain can generate the perception of sound. True silence might be impossible. Information theory: noise versus signal. In information theory, a distinction is made between signal and noise. Signal is the information you want to receive. Noise is the information you don't want. But here's the paradox. The distinction between signal and noise is not absolute. It depends on the receiver's intention. To a radio astronomer listening for signals from distant galaxies, the cosmic microwave background is noise that obscures the signal. But to a cosmologist studying the Big Bang, the cosmic microwave background is the signal, and other radio sources are the noise. The same physical phenomenon is signal to one listener and noise to another. This reveals that there is nothing intrinsically noisy or signaling about any information. The categorization depends on the observer's purpose. But there's something deeper. In quantum information theory, there is the concept of quantum noise. In quantum systems, noise is not just random disturbance. Quantum noise has structure. It follows probability distributions. It can be characterized mathematically. Furthermore, quantum noise might not be eliminable. Some theorists argue that at the quantum level, noise is fundamental to reality. Uncertainty is not a limitation of our measurement. It's woven into the fabric of reality. Heisenberg's uncertainty principle states that certain pairs of properties, like position and momentum, cannot both be known with perfect precision. There is an irreducible uncertainty, an irreducible fuzziness. This looks like noise, but it might be more fundamental. It might be that nature itself is inherently uncertain, inherently noisy at the quantum level. If quantum uncertainty is fundamental, then noise is not a corruption of signal. Noise is part of the basic structure of reality. Some theorists have suggested that consciousness itself might arise from quantum noise. If the universe is fundamentally uncertain at the quantum level, then perhaps the emergence of unpredictable creative events, what we experience as choices and possibilities, is driven by this fundamental quantum noise. From this perspective, consciousness is not a glitch or anomaly. It is a consequence of the inherent noisiness of reality. The universe is not deterministic. At every moment, quantum probabilities collapse into actual outcomes. Consciousness might be what it feels like, from the inside, to be a system at the edge of quantum uncertainty, making choices that are neither fully determined nor fully random. The apparent randomness, the noise, the uncertainty, these might be the signature of freedom and creativity. Noise, then, is not purely negative. Noise is the source of novelty. Without noise, the universe would be perfectly predictable, perfectly deterministic, perfectly static. The noise is what allows new things to emerge. The noise is what makes change and growth possible. Silence as a philosophical tool. Ludwig Wittgenstein, one of the most influential philosophers of the 20th century, ended his most famous work, the Tractatus Logico-Philosophicus, with a remarkable sentence: "Whereof one cannot speak, thereof one must be silent." What he meant was that there are aspects of reality and consciousness that cannot be captured by language. You can speak about facts, about how the world is, but there are things that lie beyond the reach of language, the mystical, the sacred, the absolutely subjective. About these things, silence is the only honest response. This is a radical position. It suggests that philosophy, which is fundamentally about speaking and argumentation, has limits. There are truths that cannot be articulated. There are experiences that cannot be captured by words. The deepest truths might lie in silence. Eastern philosophical traditions have long emphasized the limits of language. In Taoism, the Tao Te Ching begins with the statement, "The Tao that can be named is not the eternal Tao." The deepest reality cannot be captured by language or conceptual categories. Language divides reality into subjects and objects, causes and effects, things and properties. But the ultimate reality transcends all divisions. It can only be approached through silence, through the emptying of concepts. Zen Buddhism also emphasizes silence. Enlightenment is often described as wordless understanding. A Zen master might respond to a question with a gesture or a story rather than an explanation. The point is not the words, but what lies beyond the words. Silence, then, is not the absence of meaning. Silence is often pregnant with meaning. Silence is where the deepest understanding can emerge. In psychotherapy, a therapist learns to use silence as a tool. When a client reaches the limits of what they can articulate, a moment of silence allows the unconscious to surface. Insights often emerge in silence rather than in the flood of words. In music and art, silence is used to create space where the audience's imagination can work. A powerful piece of music often ends not with a bang, but with silence, allowing the listener to sit with the music, to integrate it, to discover its personal meaning. The concept of silence as a philosophical tool challenges the assumption that more speech is better, that louder voices win arguments. In a noisy world, silence becomes radical. The willingness to be silent, to admit what cannot be said, to let something remain unsaid, these become acts of epistemological humility. Silence becomes a way of respecting the limits of understanding. Silence becomes a way of honoring the mysteries that cannot be penetrated by reason. In this view, silence is not empty. Silence is full of potential. Silence is where meaning waits to be discovered. String theory and vibration as fundamental. Modern physics proposes something radical. Everything in the universe is made of tiny vibrating strings. These strings are so small that they can never be directly observed. They are smaller than atoms, smaller than electrons, smaller than quarks. Yet according to string theory, these infinitesimal vibrating strings are the ultimate building blocks of reality. Everything that exists, all matter, all energy, all forces, is made of strings vibrating at different frequencies. Electrons are strings vibrating at one frequency. Photons are strings vibrating at another frequency. Gravity arises from strings vibrating in a particular way. The entire universe is a symphony of vibrating strings. What makes this theory remarkable is how it connects to sound. Throughout history, sound has been the gateway to understanding vibration. Pythagoras discovered that musical intervals correspond to simple mathematical ratios. This led him to believe that the universe itself operated on mathematical principles. 2,000 years later, string theory suggests he was right. The universe might be fundamentally musical. It might consist of vibrating patterns following mathematical laws. String theory is highly speculative. Many physicists doubt it will ever be empirically verified. The strings are so small, require such extreme energy to detect, that they might forever remain theoretical. Yet even if string theory is wrong in its details, it captures something true about how physics has evolved. Physics has discovered that vibration and resonance are more fundamental than we once thought. Waves are not just phenomena that occur in water or air. Waves are a basic way that reality manifests. Vibration might be more fundamental to existence than particles, more fundamental than matter itself. This reframes what sound is. Sound is not a special case of vibration. Sound is a manifestation of the most fundamental principle of existence, the principle of vibration itself. When you hear a sound, you are hearing the universe's basic principle expressing itself in a form your ear can perceive. Sound connects you to the deepest level of reality. This is not metaphor. This is what modern physics suggests. The ancient intuition that the universe is musical, that it operates on harmonic principles, that vibration is fundamental. This intuition might be vindicated by 21st century physics. The study of sound, then, is not just about one sensory mode. It is potentially the study of reality's most fundamental nature. When you listen to music, you are not just experiencing something ephemeral and subjective. You might be hearing the voice of the universe itself, the vibration of strings that compose all existence. Standing waves and stable existence. Place a vibrating string under tension and pluck it. The string vibrates, creating a standing wave. This is a wave that appears to stand still in space, with nodes, points of no motion, and antinodes, points of maximum motion. The pattern is stable. It doesn't change unless you pluck the string again. What's remarkable is that not every frequency will create a standing wave on a given string. Only certain frequencies work. These are the frequencies determined by the length of the string and the tension. A shorter string has higher frequencies. A tighter string vibrates faster. But the key insight is this: only specific frequencies produce stable vibrations. These are called the resonant frequencies or natural frequencies of the string. At any other frequency, the vibrations decay and disappear. This is true not just for strings. Every object has natural frequencies at which it vibrates stably. A bell rings at certain pitches determined by its shape and material. A building sways at certain frequencies determined by its structure. An atom has natural frequencies determined by the arrangement of its electrons. Quantum mechanics reveals that atoms are stable because they exist as standing wave patterns. An electron orbiting a nucleus is not like a planet orbiting a star. The electron is a standing wave. The orbit is stable because it contains an integer number of wavelengths. If the orbit had a non-integer number of wavelengths, it would destructively interfere with itself and collapse. Atoms exist as stable entities because they are standing waves. Atoms don't vibrate in the classical sense. They are vibration. Their stability comes from the mathematics of standing waves. This insight extends further. Molecules are stable because their atoms vibrate in patterns that reinforce each other. Molecules are made of standing wave patterns. Crystals are stable because their atoms arrange themselves in patterns where standing waves reinforce. All of material reality, every solid object, every stable structure, consists of standing wave patterns. The universe builds stability through resonance. Things that vibrate at compatible frequencies reinforce and lock together. Things that vibrate at incompatible frequencies interfere destructively and remain separate. Existence, then, is the art of matching frequencies. Two things come together and form a stable bond when their vibrational patterns are compatible. This is how atoms bond into molecules. This is how molecules bond into cells. This is how cells organize into organisms. This is how organisms relate to each other through sound. Resonance and standing waves are not just physical phenomena. They might be the fundamental principle by which existence organizes itself. The universe creates structure, stability, and complexity through the interaction of vibrating patterns. Sound teaches us this principle most directly. But the principle extends to all of reality. Everything that exists is a standing wave pattern, and what you perceive as the solid world is made of vibrations resonating in perfect patterns. Quantum entanglement and harmonic synchronization. In quantum mechanics, there is a phenomenon called entanglement. Two particles can become entangled so that they behave as a single system, even if separated by vast distances. If you measure a property of one particle, the measurement instantaneously affects the other particle. This happens faster than light could travel between them. It seems to violate the principle that nothing can travel faster than light. Einstein called it spooky action at a distance and thought it revealed a flaw in quantum theory. But experiments have repeatedly confirmed that entanglement is real. Particles are genuinely correlated across space in ways that seem to transcend distance. How can we understand entanglement? One way is through the language of resonance. Two entangled particles can be thought of as vibrating in harmony with each other. They are resonant. They are in sync. When one is disturbed, the other feels that disturbance immediately because they are fundamentally part of the same vibrational pattern. They are not separate things connected by a signal. They are aspects of a single unified system. This reframes what separation means at the quantum level. Two particles might appear to be in different locations, but if they are entangled, they are actually vibrating as a single unit. Separation, in this case, is illusion. The particles are fundamentally connected. This has been controversial and strange. It suggests that the universe at its foundation is not made of separate things. It is made of interconnected fields and waves. Separation is a phenomenon that emerges at larger scales, but at the quantum level, everything is connected through entanglement. Sound teaches us something similar. When two tuning forks are in the same room and one is struck, the other vibrates in sympathy. They are physically separate but vibrating in resonance. The separation is real. They are different forks. But the connection is equally real. They are synchronized. Quantum entanglement might be a deeper version of the same principle. Entangled particles are vibrating in perfect synchronization. The distance between them is irrelevant because they are patterns in a unified quantum field. From this perspective, entanglement is not spooky. It is natural. It is what you would expect if the universe is fundamentally a web of vibrating fields. Separation is the exception. Connection through resonance is the rule. The fact that this seems strange to us reveals how deeply we have internalized the idea that things are separate, discrete, independent. But at the quantum level, the universe is relational. Things exist in relationship to other things. Nothing is truly independent. Entanglement might be the universe showing us its true nature, that everything is connected through vibrational patterns, through resonance, through the principle of harmony that sound reveals. The wave-particle duality in sound. Light behaves as both a wave and a particle. This is called wave-particle duality. It was one of the most shocking discoveries of quantum mechanics. Light is not a wave. Light is not a particle. Light is both. It is neither. Depending on how you measure it, it behaves differently. This seems impossible. How can something be two contradictory things? The resolution is subtle. Light is fundamentally neither a wave nor a particle. Light is something for which our categories of wave and particle are inadequate. We are forced to use both descriptions because our language and conceptual frameworks don't have a third category. Sound foreshadowed this discovery. Sound was understood as a wave long before we questioned what light was. But in some contexts, sound also acts like particles. A beam of high-intensity sound can exert pressure on objects, like a stream of particles hitting them. Acoustic cavitation, the formation of bubbles in liquid due to sound waves, happens as if the sound were composed of discrete particles rather than continuous waves. Sound forces us to recognize that the wave-particle distinction might be artificial. The universe doesn't have waves and particles. The universe has excitations of fields. A field is something that has a value at every point in space and time. The electromagnetic field, the electron field, the quantum fields that underlie reality. These are the fundamental entities. Waves are organized patterns in fields. Particles are quantized excitations of fields. Both are descriptions of the same underlying phenomenon. The wave-particle duality is resolved when you realize that neither waves nor particles are truly fundamental. Fields are fundamental, and fields can exhibit both wave-like and particle-like behavior depending on context. Sound reveals this principle because sound is literally vibration of a material medium. Sound is an excitation of the acoustic field, the field that represents the density and pressure of matter. Sound exhibits wave properties because it is organized patterns of vibration. But sound can also exhibit particle-like properties because it consists of discrete quanta of excitation. This understanding has been extended to all of physics. Matter is not made of tiny solid balls. Matter is quantized excitations of matter fields. Light is not made of tiny photons bouncing around. Light is quantized excitations of the electromagnetic field. The universe is made of fields, and vibration is how fields express themselves. From this perspective, sound is not a special case. Sound is what vibration in fields looks like when it occurs at frequencies we can hear. But the same principle applies at all frequencies, all scales. The universe is fundamentally vibrational. It is fundamentally musical. And the distinction between waves and particles dissolves when you understand that both are manifestations of the underlying reality of fields in vibration. Dimensional resonance. Do higher dimensions vibrate? Physics suggests that our universe might have more than the 3 spatial dimensions we perceive. String theory requires extra dimensions, 6 or 7 additional dimensions beyond the 3 we experience. These extra dimensions are theorized to be compactified, rolled up so tightly that they are imperceptible at the scales we can observe. But they might exist. And if they exist, what would sound in those dimensions be like? This is purely speculative, but it opens fascinating philosophical territory. If there are higher dimensions, they might vibrate. Those vibrations might generate standing wave patterns just as 3-dimensional space does. We have no organs to detect vibrations in higher dimensions. We are locked into perceiving the 3 spatial dimensions we are embedded in. But just as bats perceive ultrasound, we cannot, perhaps hypothetical beings in higher dimensions, perceive vibrations we cannot. The question becomes, what information is encoded in the vibrations of higher dimensions? String theory suggests that the properties of particles in our 3-dimensional world are determined by how the strings vibrate in the higher dimensions. The mass of an electron, the charge of a quark, the properties of fundamental forces, all might be determined by vibration patterns in dimensions we cannot perceive. If this is true, then the deeper nature of reality is hidden in dimensions we cannot access. The sounds of those higher dimensions would carry information about the deepest structure of existence. We would be deaf to them. This raises a profound philosophical point. The limitations of our perception don't define the limits of reality. Reality is far richer than what we can perceive. We live in a corner of a vast universe that extends in directions we cannot sense. Just as a 2-dimensional being drawn on a piece of paper cannot conceive of the 3-dimensional world above their surface, we cannot conceive of higher dimensional reality. But that doesn't mean it isn't there. The study of sound reveals that reality has structure that is invisible to us. Infrasound and ultrasound, quantum fields, virtual particles in the vacuum. All these are aspects of reality that exist beyond our direct perception. Higher dimensions might be another aspect of reality beyond our grasp. The mystical intuition that the universe is far larger and stranger than ordinary perception reveals has some support from modern physics. We are not perceiving anything close to the full reality. Our sense organs have limits. Our minds have limits. We see a tiny fraction of what is. And what we don't see, the vast dimensions of reality beyond our perception, might be waiting there, vibrating with information we cannot access. Sound is our closest gateway to understanding what lies beyond direct perception. Sound reveals invisible dimensions of reality. Perhaps in studying sound deeply enough, we approach the edge of what consciousness can know about dimensions beyond our perception. The phonograph, capturing vibration in matter. In 1877, Thomas Edison made a remarkable discovery. He created a device called the phonograph that could record sound and play it back. This was revolutionary. Sound is evanescent. A sound wave travels through air and disappears. It was gone the moment it was created. Sound had never been captured, preserved, stored. It was pure present tense. Once it occurred, it was gone forever. But Edison's phonograph changed this. The phonograph had a membrane that vibrated in response to sound. This vibrating membrane was connected to a stylus that traced an indentation in a rotating cylinder of tin foil. The vibrations were literally carved into the physical material. When the cylinder rotated again with the stylus held lightly against it, the indentations made the membrane vibrate again, producing sound. Edison had imprisoned vibration in matter. He had turned sound, something immaterial and evanescent, into something material and permanent. This was philosophically profound. It revealed that sound is information. Sound is a pattern of vibrations. That pattern could be encoded in physical form. Once encoded, the pattern could be retrieved and made audible again. This principle transformed human culture. For the first time, humans could preserve the voices of people after they died. You could hear your grandmother's voice years after she had passed. You could hear great musicians perform over and over. Sound became something that could be bottled, stored, sold, distributed. The phonograph created the possibility of mass distribution of recorded sound. Radio waves could carry the encoded sound across distances. Eventually, digital technology would create perfect copies of that encoded information. The implications were staggering. Before the phonograph, music was necessarily ephemeral. A concert happened once, and then it was gone. Musicians had to be physically present to create sound. After the phonograph, music could be separated from the presence of the musician. A performance could be captured and replayed infinitely. This changed what music is. It changed the economics of music. It changed how humans relate to sound. But there's a deeper implication. The phonograph revealed that sound is information encoded in vibration. And information can be transferred between different media. Vibrations in air can be transferred to vibrations in tin foil or vinyl or magnetic tape or digital bits. The medium changes, but the information remains. This is the principle that underlies all recording technology. It's also a principle that extends beyond sound. Any pattern of vibration, any information, can theoretically be captured, transferred, and stored. This raised the question, what is being preserved when you record sound? Is it the sound itself? The sound is vibrations in the musician's voice, vibrations in air, vibrations in a stylus. All these vibrations represent the same information. When you play back the recording, you get vibrations in air that your ear interprets as sound. The experience is different. You hear a speaker instead of a person, but the information is the same. This points to something profound. Information is more fundamental than the medium that carries it. The same information can be embodied in different physical forms. The universe, at its foundation, might be made of information. And that information can be expressed in many different ways, in sound, in light, in vibrations, in the structure of matter. Radio and the invisible ether. In the late 1800s, scientists discovered that they could transmit sound through empty air without wires using radio waves. Radio waves are electromagnetic radiation, the same phenomenon as light, but at lower frequencies. These waves travel at the speed of light and can be detected by appropriate receivers. A human voice could be transmitted through space, through air, invisible and inaudible, until it reached a radio receiver that converted the waves back into sound. This was magic made real. A disembodied voice traveled through space and arrived at distant ears. Humans had created ghosts, voices without bodies, sounds without sources, speakers who were simultaneously everywhere and nowhere. The technology revealed something profound about the nature of communication. Information does not require a material carrier that touches us directly. Information can travel through space itself, invisible and intangible, and still arrive at our ears intact. But radio also required an assumption that turned out to be wrong. Scientists believed that radio waves traveled through a medium called the luminiferous ether, an invisible substance that filled all of space. Light and radio waves were thought to be oscillations in this ether. The ether was necessary because it was hard to imagine waves propagating through empty space. Waves need a medium to propagate through. But the ether had a problem. If it existed, and if Earth moved through it, then the speed of light should be different, depending on the direction Earth was moving through the ether. But experiments showed that the speed of light is always the same, regardless of direction or the motion of the observer. This was a profound mystery. Einstein resolved it by proposing that the ether doesn't exist. Light doesn't need a medium. Light is something fundamentally different from sound. Light is an electromagnetic field oscillating in spacetime itself. Spacetime is not a substance that waves travel through. Spacetime is the stage on which waves occur. This realization transformed physics, but it happened because of radio. The technology of transmitting sound through air without wires forced physicists to confront the question of how waves could propagate through space. And in answering that question, they discovered something about the deep structure of reality. Radio also changed how humans experience sound and community. Radio made it possible for millions of people to hear the same broadcast simultaneously. People separated by distance could share the same experience. This created a new form of collective consciousness. Millions of people listening to the same words, the same music, at the same time. This was unprecedented. It changed politics, culture, entertainment. The technology that emerged from trying to transmit sound wirelessly created new forms of human community. It revealed that community doesn't require physical presence. Community can be created through shared information transmitted through space. The digital revolution. Sound as data. When sound is converted to digital form, it becomes data. A microphone converts vibrations in air to electrical signals. An analog to digital converter samples these electrical signals thousands of times per second and assigns each sample a number. 16-bit CD. Quality audio takes 44,100 samples per second of each channel. Each sample is encoded as a 16-bit binary number. The result is a string of ones and zeros that represent sound. Once sound becomes data, it can be manipulated, copied, transmitted, and stored with perfect fidelity. A digital recording can be copied an infinite number of times without any loss of quality. The 1000th copy is identical to the original. Digital sound can be transmitted over the internet as pure information. It can be compressed, encrypted, embedded in other data. Digital sound has become just another type of information, subject to the same rules as text or images. This transformation had consequences. It meant that the economic model of music distribution changed. Physical copies of recordings, vinyl records, cassettes, CDs, were necessary because making those copies was the only way to distribute sound. But digital copies are infinitely replicable at zero cost. This disrupted the music industry and forced it to reimagine how music is distributed and monetized. But there's a philosophical consequence. Digital sound is information twice removed from the original vibrations. The original vibrations are converted to electrical signals. The electrical signals are converted to numbers. To hear the sound, the process reverses. Numbers become electrical signals, which become vibrations. At each stage, information could theoretically be lost. And indeed, digital encoding is not perfectly lossless. Lossy compression algorithms throw away information that human hearing typically doesn't notice. MP3 files throw away roughly 90% of the data of the original recording. Yet to human ears, the compression is nearly imperceptible. This reveals something about perception. Perception is selective. Your ears and brain don't perceive all the information in a sound wave. They perceive some aspects and ignore others. Digital compression exploits this. The compression algorithm identifies which information is perceptually insignificant and discards it. This works because perception is not about receiving all possible information. Perception is about extracting the information that matters. Digital technology has also changed the nature of sound itself. When sound is data, it can be edited, processed, transformed in ways that aren't possible with analog sound. A singer's voice can be pitch corrected so perfectly that every note is dead center. Background noise can be removed. Effects can be added. The authentic sound of the human voice, with all its imperfections and character, can be replaced with a processed version. This has changed how music is created and what we accept as music. A perfectly pitch-corrected, heavily processed voice sounds artificial to our ears. Yet we've become so accustomed to it that natural, unprocessed singing now sometimes sounds wrong. Spatial audio and the illusion of place. A stereo recording uses two channels to create the illusion of space. The left channel carries sound from the left. The right channel carries sound from the right. When you listen on stereo headphones, your brain interprets the different timing and intensity of sound in each ear and creates an illusion of space. You perceive sounds coming from left and right, even though you're listening to speakers an inch away from your ears. Binaural recording takes this further. A binaural recording is made using microphones placed in the ear canals of a dummy head or a human. These recordings capture not just the left-right stereo difference, but also all the subtle differences that your ears create through their own shape. When you listen to a binaural recording on headphones, the illusion of spatial location is remarkably convincing. A sound can seem to come from above you, behind you, far away. Your brain is completely fooled. It perceives the location in three-dimensional space, even though the sound is coming from two tiny speakers. Surround sound systems take this further by adding speakers above, below, and behind the listener. This creates an even more convincing illusion of three-dimensional space. Some theaters use Dolby Atmos, which can place individual sounds precisely in three-dimensional space around the listener. Your brain creates a detailed map of where each sound is located. But here's the remarkable part. This sense of space is entirely constructed by your brain. The sound waves traveling through air have no sense of location. A sound wave is just vibration propagating outward. Your brain constructs the sense of location by interpreting differences in timing and intensity between your two ears. It calculates the angle from which the sound is arriving, based on which ear hears it first, and which ear hears it louder. It uses the shape of your ears to extract information about whether the sound is above or below you. All of this calculation happens unconsciously. The spatial awareness feels immediate and direct, but it's actually an elaborate construction. Your brain is solving a complex mathematics problem in real time and presenting you with the result as perception. This reveals something about all perception. It is constructed. What you perceive is not reality directly. It is your brain's construction based on sensory input, and that construction can be manipulated. The right pattern of sounds can convince your brain that a sound is coming from a location where no speaker exists. Virtual reality systems exploit this. By carefully controlling the spatial audio, they can create a convincing illusion of being in a different place. You can hear footsteps approaching from behind and instinctively turn around, even though nothing is actually there. The brain's construction of spatial sound is so powerful that it can overpower your knowledge that you're listening to speakers. Artificial intelligence and machine listening. In recent years, artificial intelligence systems have learned to listen in ways that surpass human capabilities. AI can analyze voice recordings and identify emotional state with accuracy greater than humans. AI can detect health conditions from coughs and breathing patterns. AI can generate synthetic speech that sounds remarkably human. AI can analyze music and predict what note comes next. These capabilities reveal something remarkable. Sound carries information that humans process without being aware of it. An AI system analyzing a voice can detect subtle patterns in pitch, timing, and tone that correlate with depression or anxiety. Humans listening to the same voice might not consciously notice these patterns, but they unconsciously sense that something is wrong. The AI has made explicit what humans process implicitly. Machine listening also reveals the redundancy in sound. A neural network trained on millions of songs can predict the next note with surprisingly high accuracy. This reveals that music is highly structured. Once you've learned the patterns of a genre or composer, you can anticipate what comes next. The future of sound is being shaped by AI. AI can enhance audio clarity, remove background noise, synthesize natural-sounding speech in any language. AI can compose music in any style. Some musicians use AI as a tool to explore creative possibilities. Others see AI music generation as a threat to human musicians. But the deeper question is, what does machine listening reveal about sound and consciousness? If a machine can learn to hear emotions in a voice, does that mean emotion is a property of the sound itself? Or does it mean that machines can detect the correlates of emotion without truly understanding what emotion is? Can a machine truly hear, or just process the data patterns in sound? These questions touch on the hard problem of consciousness. Machines can process sound. Machines can extract patterns from sound. But machines presumably don't experience sound the way humans do. A machine analyzing a beautiful piece of music doesn't have the subjective experience of being moved by it. Or does it? We have no way to know what the subjective experience of a machine is, if it has any. Perhaps future AI will create consciousness. Perhaps future machines will have inner lives and will genuinely hear the beauty of music. Or perhaps consciousness requires something that machines cannot have: embodiment, mortality, the stakes that come with being a living creature. What seems clear is that sound is information. And wherever there is sophisticated information processing, whether in human brains or artificial neural networks, there is the possibility of listening. Gravitational waves, the universe's own voice. In 1916, Einstein proposed that gravity is not a force that acts instantaneously across space. Instead, gravity is a warping of space-time itself. Massive objects curve space-time the way a bowling ball curves the surface of a trampoline. And just as vibrations on a trampoline propagate outward, gravitational disturbances should propagate through space-time. Einstein called these gravitational waves, but they are so weak that detecting them seemed impossible. For nearly a century, gravitational waves remained theoretical. Then, in 2015, scientists finally detected them. Two black holes had collided and merged about 130 billion light-years away. The collision released so much energy that it created ripples in space-time. These ripples traveled across the universe and slightly warped space-time when they reached Earth. The distortion was incredibly small, about 1/10,000th the width of a proton. Yet sensitive detectors called LIGO Laser Interferometer Gravitational Wave Observatory could measure this tiny distortion. When the data from LIGO was converted to sound, it created an audible chirp, a brief sound that rose in pitch as the black holes spiraled closer and faster before merging. Humans heard the gravitational waves as sound. The universe was literally making a sound that human ears could hear. This is profound. For most of human history, humans could not hear gravity. Gravity is invisible, always present, yet silent. But gravitational waves are the sound of gravity. When the fabric of space-time vibrates, it can produce something that, when translated into frequencies we can hear, sounds like anything else. The gravitational wave from colliding black holes sounds like a brief chirp. The sound of the universe making a sound is not metaphor. It is literal. The vibration of space-time produces disturbances that can be detected and converted to audio. This opens a new astronomy. For centuries, astronomy was visual. Humans looked at the light from distant objects, but the universe produces information in many forms. Gravitational waves are produced by events that don't emit visible light, like merging black holes. By listening to the universe through gravitational wave detectors, astronomers are accessing phenomena that were previously invisible. We are learning to hear the universe's secrets. The philosophical implication is profound. Sound connects us to the deepest structures of reality. Sound is vibration, and the universe is fundamentally made of vibration. From vibrating strings to quantum fields to gravitational waves, the entire cosmos oscillates. Sound, which for so long seemed peripheral to physics, turns out to reveal something essential, that reality is fundamentally vibrational. We are living in a universe that is singing to itself. And through detecting gravitational waves, we are finally learning to hear that song. Pulsar astronomy and cosmic rhythm. Pulsars are neutron stars, the remnants left behind when massive stars explode. They are extraordinarily dense. A teaspoon of neutron star material would weigh as much as a mountain on Earth. Neutron stars spin incredibly fast. Some spin hundreds of times per second. As they spin, they emit a beam of radiation. When the beam sweeps across Earth, we detect a pulse. The pulsar appears to pulse with remarkable regularity. Some pulsars maintain timing accuracy greater than atomic clocks. The first pulsar was discovered in 1967, and the discovery was so unexpected that the scientists gave it a joke designation, LGM1, for little green men, because the signal was so regular that it seemed like it must be artificial, a signal from an alien civilization. But it turned out to be a natural phenomenon. It was a neutron star pulsar. Pulsars reveal something about the cosmos. The universe has rhythm. Pulsars pulse. They create patterns. The universe is not chaos. The universe has structure, order, periodicity. Some theorists have speculated that pulsars could be used for timekeeping. Pulsars are so regular that they could serve as a cosmic clock. Spacecraft carry recordings of pulsar signals so that lost probes could orient themselves by the pulsars they detect. The universe has given us clocks. Pulsars also reveal that stars, even in their death throes, have structure and order. A pulsar is a remnant of stellar catastrophe, the collapse of the stellar core, yet it maintains exquisite regularity. This suggests that regularity and order are fundamental to nature. Even chaos tends toward order. Even explosive violence produces rhythmic patterns. The pulsar teaches that beneath the apparent randomness of the cosmos, there is rhythm. And rhythm, once again, is fundamentally about vibration and sound. The pulsar is the universe making a sound, broadcasting a rhythmic signal across space. Astronomers can literally hear the pulse of the star, and from the pattern of pulses, they extract information. The timing of the pulses reveals whether the pulsar is being orbited by another star. The gradual slowing of the pulses reveals how the pulsar is losing energy. The pulsar speaks to us in the language of rhythm. And rhythm is sound. This reveals something deep about how the universe communicates. The universe uses vibration and rhythm to encode information. Sound, which has always seemed like a local phenomenon, something experienced through ears close to sound sources, turns out to be a cosmic principle. The universe pulses. The universe sings. Everything that vibrates is making sound. And sound is how the universe reveals its nature. The cosmic microwave background as frozen sound. In 1964, astronomers Arno Penzias and Robert Wilson were working with a sensitive radio antenna when they detected an unexpected signal. No matter which direction they pointed the antenna, the signal was there. They thought it was noise from pigeons nesting in the antenna, but the signal persisted even after they removed the birds. It turned out they had discovered something profound: the cosmic microwave background, the remnant radiation from the Big Bang itself. This radiation had been traveling through space for nearly 14 billion years. It is the oldest light we can observe. But what makes it remarkable is what cosmologists discovered within it. The cosmic microwave background is not perfectly uniform. It has tiny temperature variations, differences of about 1 part in 100,000. These variations are not random. They form patterns. And these patterns tell the story of the universe's earliest moments. Sound waves were traveling through the hot plasma of the early universe. These sound waves created regions of higher and lower density, compressions and rarefactions, just like sound waves in air. When the universe became transparent and light could escape, these sound waves froze into the patterns we now observe in the cosmic microwave background. The universe's first seconds contained sounds, vibrations in the primordial plasma. And we can now see the fossil record of these sounds. By analyzing the pattern of temperature variations in the cosmic microwave background, cosmologists can literally read the sound waves of creation. The patterns tell us about the composition of the universe, about the physics of the Big Bang, about the geometry of space-time itself. We are listening to the echoes of the universe's first moments. This is profoundly moving. The light we observe today is the same light that was created in the Big Bang and has traveled for billions of years to reach us. Within the patterns of this light is encoded the sound of creation. The universe spoke in its first moments, and we can now hear that speech. The cosmic microwave background is sound turned into light, frozen into the structure of the universe. Every aspect of what the universe is today emerged from those first vibrations. The stars, the galaxies, the structure of everything that exists, all of it grew from the acoustic patterns present at the moment of creation. This reveals something staggering. Sound might be more fundamental than anything else. The universe began as vibration. From vibration, all else emerged. The cosmic microwave background is the voice of creation still echoing across the cosmos, carrying within itself the blueprint of all that is. Exoplanet atmospheres and the physics of different worlds. As astronomers discover exoplanets, planets around distant stars, they face a question. If we found life on these worlds, what would it sound like? The answer depends on the physics of each world. Sound travels at different speeds through different atmospheres. In Earth's atmosphere, sound travels at 343 meters per second. But on Venus, with its dense atmosphere of carbon dioxide, sound travels faster, about 400 meters per second. On Mars, with its thin atmosphere, sound travels much slower, about 240 meters per second. And on worlds with even thinner atmospheres, Mercury, the Moon, sound might barely travel at all. the density and composition of an atmosphere determine how sound propagates. A world with a thick atmosphere would have different acoustics than Earth. Sounds might travel farther. The pitch of sounds might be different because sound speed affects how frequencies interact. A denser atmosphere would allow low frequencies to propagate farther. A thinner atmosphere would favor high frequencies. If intelligent life evolved on a different world, they might hear a different range of frequencies. They might perceive sound differently. They might develop language with different phonetic structures. They might make music with different scales and intervals. The physics of the world shapes perception and communication. It shapes what consciousness can hear. This reveals that consciousness is not universal. Consciousness emerges from the interaction between a mind and an environment. A mind in a dense atmosphere hears one world. A mind in a thin atmosphere hears a different world. Even the most advanced intelligences would be shaped by the physics of their world. This suggests that sound, which we have been studying as a universal principle, is also deeply contingent. Sound is not the same everywhere. It depends on the medium it travels through. The fundamental principle is vibration, but how vibration is perceived and used for communication depends on local physics. There is no universal sound. There is only vibration understood through the specific physics of each world. This has implications for the search for extraterrestrial intelligence. We might be listening for signals with the wrong frequencies or wrong propagation patterns. An alien civilization might be broadcasting in forms of sound that don't propagate efficiently in our atmosphere. They might be using frequencies we can't hear. They might be modulating information in ways we don't recognize as artificial. The search for extraterrestrial intelligence might be deaf to the actual signals being sent. This reminds us that communication depends on compatible physics and shared sensory capacities. To understand another mind, you need to understand the environment it lives in and the sensory capacities it has developed. Sound teaches that communication is not universal. Sound is local, shaped by physics, shaped by evolution. Yet the principle of vibration and resonance that underlies sound is universal. Everywhere in the cosmos, systems vibrate. Everywhere, resonance creates patterns. The language might be different, but the fundamental principle of vibration connects all consciousness in the cosmos. The search for extraterrestrial intelligence through sound. For decades, scientists have been searching for signals from intelligent extraterrestrial civilizations. The search is called SETI, the search for extraterrestrial intelligence. The primary method has been to listen for radio signals coming from space. Radio waves are a form of electromagnetic radiation, just like light, but at lower frequencies. A distant civilization could broadcast information using radio waves, and we could detect those waves with our radio telescopes. But what if extraterrestrial intelligence doesn't broadcast radio signals? What if they communicate using other forms of vibration? What if they communicate through sound, actual acoustic vibrations in their atmospheres? We would miss those signals. Our radio telescopes listen for electromagnetic radiation. We're not listening for acoustic signals coming from other worlds. Or what if extraterrestrial intelligence communicates using the most efficient medium available to them? On a water world with oceans, acoustic signals might be the best way to communicate over long distances. The signal would propagate through water more efficiently than electromagnetic waves. A civilization on such a world might develop sophisticated acoustic communication. But we wouldn't recognize it as intentional. We would dismiss it as natural ocean noise. The SETI program assumes that extraterrestrial intelligence would communicate like humans do, using broadcast signals. But intelligence might use completely different communication modalities depending on their environment and biology. An intelligence based on crystalline structures might communicate through vibrations in rock. An intelligence based on gaseous processes might communicate through acoustic vibrations in atmosphere. Each form of intelligence would use the most efficient medium available. To truly search for extraterrestrial intelligence, we might need to listen in many different ways. We need to listen for radio signals, but also for acoustic patterns we might not recognize. We need to listen to vibrations of all kinds. We need to understand that intelligence might speak in a language of vibration, foreign to our own. And we need to be humble enough to recognize that intelligence might be attempting to communicate with us right now, in forms we simply don't recognize as communication. Sound is a form of vibration. Light is a form of vibration. Gravity is a form of vibration. The universe is fundamentally made of vibrations. If extraterrestrial intelligence exists, it is vibrating in some form, creating patterns that encode meaning. Our challenge is to listen broadly enough to hear all the ways intelligence speaks. We must learn to hear beyond the narrow bandwidth of radio waves. We must learn to listen as the universe itself listens, to all frequencies, all modalities, all forms of vibration. Only then might we hear the voice of intelligence calling to us from across the cosmos. Why beauty exists without purpose. Here is one of the deepest puzzles in philosophy. Why does beauty exist? From a strict evolutionary perspective, beauty should not exist. A human who devoted their entire life to creating beauty, to making music, to crafting art, would be less likely to survive and reproduce than a human focused entirely on finding food and mates. Beauty serves no survival purpose. Yet humans everywhere create it. Every human culture creates art, music, poetry. Even in the midst of poverty and hardship, humans make beautiful things. This suggests that consciousness is not purely driven by survival and reproduction. Consciousness has goals beyond the biological imperatives. Consciousness seeks meaning. Consciousness seeks beauty. Why would beauty have evolved if it serves no survival purpose? One possibility is that beauty is a byproduct. Perhaps we evolved the capacity to appreciate beauty as a side effect of other capacities that do serve survival. Perhaps we evolved to recognize patterns, and beauty exploits pattern recognition. Perhaps we evolved to bond socially, and making beautiful things together bonds people. But this doesn't fully explain it. Beauty seems too important, too central to human life to be merely accidental. Another possibility is that beauty does serve survival, but indirectly. A human who can find beauty in life, who can create meaning through art, might have better mental health. Better mental health might increase survival chances. A community that shares beautiful art and music might bond more tightly and survive as a group more effectively. But even this explanation feels incomplete. It reduces beauty to a tool, a means to survival. Yet beauty seems to matter for its own sake. The deepest answer might be this: consciousness is fundamentally about creating meaning. Humans are not purely biological machines. Humans are meaning-making creatures. We search for significance, for order, for purpose. Beauty is what meaning feels like when it emerges from the organization of sensory experience. Music is organized sound that creates meaning. Art is organized visual experience that creates meaning. The human need to create and appreciate beauty reflects the fundamental nature of consciousness. It is driven to find meaning even in an indifferent universe. In this view, beauty is not a luxury. It is necessary. Without beauty, without meaning, consciousness would be intolerable. The meaningfulness of beauty might be what makes life worth living. This suggests that the study of sound and music, the study of beauty itself, is not peripheral to understanding consciousness. It is central. In seeking to understand why humans make music, we are seeking to understand why consciousness exists at all. And the answer might be that consciousness exists because existence wants to know itself. And consciousness does this through beauty, through meaning-making, through the creation of order from chaos. The universe, perhaps, is conscious of its own beauty through the consciousness of humans. And that might be the ultimate purpose of beauty, not to serve survival, but to serve meaning. The problem of universality and difference. All human societies make music, yet the music of different cultures is radically different. A Beethoven symphony sounds nothing like a Mongolian throat-singing performance. An Indonesian gamelan orchestra produces sounds that are alien to Western ears. Native American flute music follows different scales and harmonic principles than African drumming. If music is universal, if all humans make it, then why are musical traditions so wildly different? This is the fundamental puzzle of music, universality coupled with radical cultural diversity. One answer comes from developmental psychology. All babies respond similarly to music. Lullabies across cultures share acoustic properties: high pitch, slow tempo, repetitive patterns. Babies everywhere find these acoustic properties soothing. This universality suggests that there is something wired into human neurology that responds to certain patterns of sound. But as children grow, they are enculturated into specific musical traditions. They learn their culture's scale system, its rhythmic patterns, its musical values. By adulthood, a person finds their own musical tradition beautiful and unfamiliar traditions strange or unpleasant. This process of cultural learning shapes musical preference, but this still doesn't fully explain the diversity. If we all have similar brains, why would different cultures develop such different musical systems? The answer lies in the principle of cultural drift and aesthetic exploration. Given a universal capacity for music, different cultures explore the vast space of musical possibilities in different directions. One culture emphasizes complex rhythmic patterns. Another emphasizes harmonic complexity. Another emphasizes vocal technique. Another emphasizes the sustained tones of bowed instruments. There are infinite ways to organize sound musically. Each culture has discovered some of those ways and refined them. This is analogous to language. All humans have the capacity for language, yet languages are radically different. The sounds that matter in one language are irrelevant in another. The grammatical structures vary dramatically, yet all languages accomplish the same fundamental task: communication. Languages are solutions to the same problem: how to convey meaning through organized sound, but they are different solutions. Music is similar. All musical traditions are solutions to the same problem: how to create meaning through organized sound. But different cultures have discovered different solutions. The universality of music reflects the universality of consciousness. All humans seek meaning through organized sound. But the particular forms that meaning takes are culturally constructed. This reveals something important about consciousness. It is fundamentally universal in its capacities, but infinitely diverse in its expressions. We all want to understand beauty. We all find it in organized patterns. But what counts as beautiful is learned. The intersection of universality and diversity shows that consciousness is not a fixed thing. It is a capacity for learning, for being shaped by culture, for developing preferences and values. Music teaches that being human means having universal capacities that are always expressed through particular cultural traditions. Sound as communication beyond language. Words can describe facts. It rained today. The temperature is 25 degrees. He ate breakfast. Words are excellent at conveying propositional content, statements about how the world is. But there are aspects of experience and consciousness that words seem unable to capture. How do you describe the feeling of joy? the ache of loss, the strangeness of déjà vu, the taste of a strawberry to someone who has never eaten one. There is a gap between experience and language. Music fills that gap. Music can convey emotion without words. A minor chord expresses sadness. A dissonant chord expresses tension. A major chord expresses joy. The ascending motion of a melody expresses hope. These emotional meanings are conveyed through the patterns of sound themselves, not through words. This suggests that there are multiple forms of meaning. There is propositional meaning, the meaning of words and sentences. There is emotional meaning, the feeling conveyed by music. There is aesthetic meaning, the satisfaction of perceiving beauty. There is existential meaning, the sense that something matters, that something is significant. These forms of meaning can exist independently of language. A purely instrumental symphony can be deeply meaningful without a single word being spoken. A single long tone held on a cello can move a listener to tears without any language involved. This reveals that human consciousness is not fundamentally linguistic. Language is one way consciousness expresses itself. But there are forms of consciousness, emotional, aesthetic, intuitive, that exist prior to language and are not fully captured by language. Music is the art of expressing these non-linguistic forms of consciousness. The power of music is that it reaches beyond words. It can convey what words cannot. It can speak to parts of consciousness that language doesn't touch. This is why people turn to music for solace. Words might say, "I understand your grief," but a song can feel that grief alongside you. Words can describe a moment, but music can make you feel what it was like to be in that moment. The existence of music as a fundamental human activity reveals that consciousness is deeper and broader than language. We are not beings who think primarily in words and then convert our thoughts into music. We are beings who experience emotion, beauty, and meaning directly through organized sound. Language is built on top of this pre-linguistic consciousness. But music is more ancient. Music is how consciousness first learns to express itself. And music remains, perhaps, the truest language of consciousness. The language that can express what nothing else can reach. The ethics of attention in a noisy world. In the modern world, we are bombarded with sound. Advertisements assault us with jingles. Background music plays in stores and elevators. Notifications ping from our phones. Voices and music stream constantly from our devices. The acoustic environment is saturated with intentional sound competing for our attention. In this environment, true listening becomes rare. True listening requires quiet. It requires the capacity to attend to one thing deeply, to be present with sound, to let it affect you. In a world of constant noise, this capacity is under threat. The skill of listening is atrophying in many people. This has ethical implications. The willingness to listen to another person, truly listen, without planning what you'll say next, without dividing your attention, is an act of respect. You are saying, through your attention, that this person matters, that their truth is worth receiving. When we stop listening, when we become so used to noise that we cannot focus on a voice, we lose something ethically important. We lose the capacity to recognize the other. We lose the capacity for empathy. But there's something deeper. True listening requires a kind of surrender. You must quiet your own thoughts, your own agenda, your own need to be right. You must open yourself to being changed by what you hear. This surrender is difficult. It requires trust. It requires vulnerability. In a world of relentless stimulation, surrender becomes harder. We become defended against input. We close ourselves against being affected. This defensive posture might be necessary in a noisy world, but it comes at a cost. It closes us off from being moved by beauty. It closes us off from connection with others. The ethics of attention in a noisy world is the ethics of choosing what we allow to affect us. It is the choice to create silence, to listen deeply, to be vulnerable to beauty and meaning. This is not easy. It requires resistance against the constant pull of noise, but it might be necessary for preserving our humanity. In a noisier and noisier world, the ability to listen, truly listen, becomes an increasingly rare and precious capacity. And the willingness to listen might become the most radical ethical act available to us. The problem of artificial creation. In 1997, a computer program called Deep Blue defeated the world chess champion Garry Kasparov. This was shocking. Chess was thought to require intelligence, creativity, strategy, yet a machine could beat the best human. In music, a similar shift is happening. Artificial intelligence can now compose music in any style. AI can generate speech that sounds human. AI can analyze music and predict the next note. Some musicians collaborate with AI. Some see AI as a creative partner, expanding the possibilities of music. Others see AI as a threat, as the commodification of creativity, as the elimination of human meaning from art. The philosophical question is, does music require human intention to be meaningful? Can artificial sound, music generated by algorithms following statistical patterns in training data, carry meaning the way human music does? When a human composes music, the composition expresses something about that human. It expresses their values, their emotions, their vision. When an AI generates music, what does it express? The AI expresses nothing. The AI has no emotions, no values, no vision. It is a statistical model that has learned patterns from human music. But the generated music is not the expression of anything. It might sound beautiful. It might follow the patterns of beautiful music. But it seems to lack something that human music has: intentionality, meaning, the imprint of a conscious creator. Yet this raises a deep question. What is meaning in music? Is meaning something that comes from the composer's consciousness? Or is meaning something that emerges in the listener's consciousness? If a listener hears a beautiful piece of music and doesn't know whether it was composed by a human or an AI, does the meaning change when they learn the truth? Many people say yes. Knowing that a human composed the music, made choices, expressed something of themselves, this knowledge makes the music meaningful in a way that AI-generated music cannot be. But if the listener's subjective experience is identical in both cases, if the music sounds the same and moves them the same way, then where does the extra meaning come from? Perhaps it comes from the listener's imagination. The listener imagines the human composer struggling to express something, refining the work, pouring themselves into it. The listener's knowledge that a conscious being created the work makes the listener's experience richer. But this meaning is, in a sense, added by the listener, not inherent in the music. This raises a final question. Is consciousness required for music to be meaningful? Or is consciousness only required for the creation of music? And once created, the music has meaning independent of its creator. The answers to these questions will shape how we understand music, meaning, and consciousness as AI becomes increasingly capable of generating music indistinguishable from human creation. Acoustic signatures and hidden information. Every object has a unique acoustic signature. When you tap a wine glass, you hear a specific tone determined by the glass's shape and thickness. When you knock on a wooden door, the sound is different from knocking on metal. These sounds are not random. They encode information about the object's physical properties. Scientists now use acoustic analysis to extract information invisible to other methods. By analyzing the sounds objects make, Scientists can determine material composition, detect hidden flaws, diagnose diseases. A doctor listening to heart sounds with a stethoscope is extracting information encoded in acoustic vibrations. Different heartbeat patterns indicate different conditions. Cardiologists listen to the heart the way musicians listen to music, extracting meaning from patterns of sound. Engineers use ultrasound to listen to the interior of materials. By sending ultrasonic waves through materials and listening to the echoes, they can detect cracks and flaws invisible to the eye. Seismologists listen to the Earth through seismometers. Vibrations from earthquakes reveal the structure of Earth's interior. The planet is constantly vibrating slightly. By analyzing these vibrations, seismologists have mapped the layers of the Earth, crust, mantle, core, without ever directly observing them. They have done this through listening. This reveals something profound. Sound carries information about the hidden structure of objects and systems. The visible world is only a surface. Beneath the surface, structures and properties are encoded in vibration. By learning to listen properly, you can access information about the deep structure of reality. This principle extends beyond physical objects. The human voice carries information about mental and physical health. Speech analysis can detect depression, anxiety, and even some diseases. The pattern of speech, not the words, but the acoustic qualities, reveals the speaker's internal state. Machines are now trained to listen for these patterns. They can detect disease from the sound of a cough, assess mental state from tone of voice, predict future health problems from acoustic features. Sound is an information-rich signal. Every vibration carries data. The challenge is learning to listen in ways that extract that information. This suggests a general principle. Reality is informationally rich. Every aspect of the world encodes information. Sound is just one channel. Light carries information. Vibrations in matter carry information. The quantum vacuum carries information. The universe is fundamentally informational. And consciousness is what emerges when a system becomes sophisticated enough to process information, to extract meaning from patterns, to listen to the signals the world is constantly sending. The problem of qualia, subjective experience. When you hear middle C, your subjective experience of that note is unique to you. It has a particular quality, what philosophers call qualia. The redness of middle C, the feeling of it, the subjective taste of that sound. This quality is private. No one else will ever know exactly what middle C feels like to you. You could describe the frequency, 262 Hz. You could describe the objective neural activity, which neurons fire, which brain regions activate. But none of this description captures what it feels like, from the inside, to hear middle C. This is the problem of qualia, and it is perhaps the deepest puzzle in philosophy of mind. We can explain everything about the physics of sound. We can map every synapse in the auditory system. We can predict with perfect accuracy what the neural response will be to any sound. And yet, we cannot explain why this particular neural pattern feels like this particular sound. Why should any neural pattern feel like anything at all? This gap between the objective description and the subjective experience is called the explanatory gap. Some philosophers argue that this gap reveals something fundamental. Consciousness cannot be reduced to physics. There is something non-physical about subjective experience. But other philosophers argue that the gap just reveals the limits of our current understanding. Perhaps future neuroscience will explain how subjective experience arises from physical processes. Perhaps we're just missing something in our current physics. The trouble is that sound makes this problem especially vivid. Most sensory experiences seem to be about information extraction. Vision seems to be about extracting information from light. Touch seems to be about extracting information about surfaces. But sound seems to create subjective experience that goes beyond mere information. You could, in principle, process all the information in a sound without experiencing it. You could analyze the frequencies, the amplitude, the temporal structure. But this analysis doesn't capture what the sound feels like. This reveals that consciousness involves something more than information processing. It involves what philosophers call phenomenal consciousness, the felt quality of experience. This quality is real. It matters. It is what makes life meaningful. And yet, it seems impossible to explain in terms of physics alone. The study of sound reveals that the structure of knowledge has a fundamental gap. We can explain the objective world perfectly, but we cannot bridge the gap to explain subjective experience. And this gap might be permanent. It might be a feature of consciousness itself. The fact that consciousness is not fully explicable through objective description might be what makes consciousness real. It might be what makes consciousness matter. Prediction and understanding. The brain does not just receive sensory information passively. The brain constantly generates predictions about what it expects to encounter. When listening to music, the brain predicts which notes will come next, based on melody and harmonic patterns. When listening to speech, the brain predicts which words are likely based on context. These predictions happen below the level of consciousness, but they fundamentally structure experience. When the prediction is correct, when the expected note arrives on time, the brain's response is minimal. The experience flows smoothly. But when the prediction is violated, when something unexpected happens, the brain sends a strong signal of surprise. This signal of prediction error is what creates conscious attention. From this perspective, understanding is fundamentally about prediction. You understand something when you can predict how it will behave. You understand music when you can anticipate the next development. You understand another person when you can predict how they will respond. You understand the world when you can accurately predict what will happen next. This reframes what knowledge is. Knowledge is not a collection of facts. Knowledge is the ability to predict. Knowledge is the ability to build accurate models of how things work. Sound is particularly important for understanding because sound unfolds in time. You cannot take in a whole sound at once. You must predict the future and compare those predictions to what arrives. Your entire experience of sound is structured by prediction. This principle extends to all knowledge. All understanding is fundamentally about prediction. The scientist who understands a phenomenon can predict its behavior. The engineer who understands a material can predict its properties. The psychologist who understands people can predict their behavior. Understanding is prediction. But this raises a question. What about understanding things that don't have predictable behavior? What about understanding consciousness itself, which is free and creative and deliberately unpredictable? Perhaps true understanding of consciousness requires accepting that it is not fully predictable. Perhaps understanding consciousness means recognizing that it has degrees of freedom, that it can violate predictions, that it can be creative. In this case, the model you build must include the recognition that the system can surprise you. You understand consciousness by understanding that consciousness resists complete prediction. And perhaps this is why consciousness is so hard to study. Consciousness is by nature somewhat unpredictable. A purely predictive model of consciousness will fail to capture something essential about it, its freedom. The limits of representation. Sound can be represented as a waveform, a graph showing air pressure over time. Sound can be represented as a frequency spectrum, showing which frequencies are present. Sound can be represented as a neural activation pattern, showing which brain regions are active. Sound can be represented as a sequence of bits, digital data. Each of these representations captures something true about sound. But no single representation captures everything. Each representation is a translation. The original sound, vibrations in air, is translated into visual form waveform, into mathematical form frequencies, into neural form brain activity, into digital form bits. In each translation, something is lost and something is added. The waveform captures the temporal structure of sound, but not the subjective experience. The frequency spectrum shows which frequencies are present, but not how they change over time. The neuroactivity pattern shows that the brain is responding, but not what the experience is like. The digital representation is abstract and can be perfectly copied, but is removed from any sensory reality. None of these representations is the sound itself, and together, they do not add up to the sound itself. This reveals something about the limits of representation. There is a gap between the thing itself and any representation of the thing. This gap is not just a limitation of current technology. It is fundamental. The thing itself, the sound, the vibration, the lived experience of hearing, is not the same as any representation of the thing. This has implications for knowledge. Science works through representation. Science takes phenomena and represents them mathematically, graphically, verbally. Science is the art of finding better and better representations. But science can never represent things completely. There will always be a remainder, aspects of reality that resist complete representation. For sound, this remainder is particularly clear. The subjective experience of sound cannot be completely represented. A complete description of the physics and neurology of hearing will never fully capture what it is like to hear a beautiful piece of music. This doesn't mean the scientific representations are not valuable. They are. They tell us true things about sound, but they are incomplete. Complete understanding would require not just representations, but direct experience. And direct experience is always singular, always particular, always tied to a specific consciousness, perceiving a specific sound at a specific moment. The limits of representation reveal the limits of objective knowledge. There are truths that can only be known through experience, that cannot be fully translated into representations. And these experiential truths might be more fundamental than the representational truths of science. Toward a philosophy of vibration. Through studying sound, we have encountered principles that extend far beyond sound itself. Vibration appears to be fundamental. Resonance appears to be universal. The relationship between observer and observed is deeply entangled. Information is encoded in patterns. Consciousness is fundamentally about prediction and surprise. There is an explanatory gap that cannot be bridged by physics alone. These insights might form the foundation of a new philosophy, a philosophy of vibration. This philosophy would hold that reality is fundamentally vibrational. At every level, quantum fields, atoms, molecules, organisms, planets, stars, galaxies, systems vibrate. And vibration creates standing waves, which create stable patterns, which create stable patterns, which create structure. The universe builds itself through resonance. Things that vibrate at compatible frequencies bond together. Things that don't resonate remain separate. From this vibrational foundation, consciousness emerges. Consciousness is what it feels like, from the inside, for a system to vibrate and resonate. Consciousness is the subjective aspect of vibrational patterns. When vibrations become sufficiently complex and organized, consciousness emerges. And consciousness is fundamentally about resonance, about matching internal patterns to external patterns, about building models, about predicting. From this philosophical perspective, sound is not a peripheral phenomenon. Sound is the most direct expression of the fundamental vibrational nature of reality. When you hear sound, you are perceiving vibration directly. You are directly encountering the principle that structures all of reality. This philosophy suggests that the universe is fundamentally relational. Things don't exist in isolation. They exist in relationship to other things. They resonate with each other. They influence each other. The apparent separation between things is less fundamental than the connections between them. A philosophy of vibration emphasizes connection over separation, relationship over isolation, resonance over discord. This has implications for ethics and meaning. If everything is fundamentally connected through vibration and resonance, then harming one part harms the whole. If consciousness is fundamentally about resonance, then the deepest ethical principle is resonance with other consciousness. To treat others well is to resonate with them, to recognize their vibration as part of the same cosmic symphony. The philosophy of vibration, emerging from the study of sound, might provide a framework for understanding reality, consciousness, ethics, and meaning. It might show us that sound is not just one phenomenon among others. Sound is the voice of the universe speaking to us, in the language it uses to speak to itself. Sound as a bridge between disciplines. Throughout this exploration, sound has revealed itself as a bridge. Sound bridges physics and consciousness. Sound bridges mathematics and emotion. Sound bridges the objective and the subjective. Sound bridges the material and the meaningful. Few phenomena illuminate so many different aspects of reality. A physicist studying sound learns about waves, about how vibrations propagate through media. A neuroscientist studying sound learns about how the brain processes information and constructs perception. A psychologist studying sound learns about emotion, about how acoustic patterns move the human heart. A philosopher studying sound learns about consciousness, about the gap between objective description and subjective experience. An artist studying sound learns about beauty, about how patterns of vibration can create meaning. Each discipline brings its own insights, and sound accommodates all of them without being reducible to any single one. This suggests something important. Sound is not primarily a topic within physics, neuroscience, psychology, philosophy, or art. Sound is a phenomenon that transcends disciplinary boundaries. Sound can only be fully understood through a synthesis of insights from many disciplines. The study of sound teaches us that reality itself might be irreducibly multidisciplinary, that the deepest understanding requires insights from physics and consciousness studies, from mathematics and art, from biology and philosophy. Sound reveals that the universe is not simply describable in the language of any single discipline. The universe is too rich, too intricate, too alive for any single conceptual framework to capture. We need many frameworks, many languages, many ways of knowing. And we need to let them speak to each other through phenomena like sound that reveal connections across the disciplines. Perhaps this is one of the deepest lessons of studying sound, that meaning and truth are fundamentally multidimensional. That understanding requires us to hold multiple perspectives simultaneously, that the full truth about anything, even something as seemingly simple as sound, is richer than any single discipline can express. The participatory nature of reality. Throughout this journey, we have encountered a recurring theme. Consciousness is not a passive observer of reality. Consciousness actively participates in creating reality. The brain doesn't just receive sensory information. The brain predicts and shapes perception. Attention doesn't just select information that's already out there. Attention constructs experience. Measurement in quantum physics doesn't just observe. Measurement determines outcomes. These insights suggest something radical. Reality is fundamentally participatory. The distinction between observer and observed is not as fundamental as we usually assume. Consciousness and reality are not separate. They are entangled. The universe is not a stage where conscious observers watch pre-scripted events. The universe is a creative act in which consciousness and reality mutually shape each other. Sound illustrates this principle vividly. Sound does not exist in isolation. Sound exists in the interaction between vibrating objects and listening ears. The vibrations alone don't make sound. The ears alone don't make sound. Sound is the meeting place between vibration and consciousness. Sound only exists in this participatory relationship. When you listen to music, you are not passively receiving information from the music. You are co-creating the experience. Your attention shapes what you hear. Your memory and expectations shape how you interpret the sounds. Your emotional state shapes how the music affects you. The same music heard by different people in different states of mind produces different experiences. The music doesn't have a single objective meaning that everyone receives equally. The meaning emerges in the relationship between the music and the listener. This participatory understanding of reality has profound implications. It suggests that you are not separate from the universe. You are part of it. Your consciousness is not trapped inside your head, observing a world outside. Your consciousness is woven into reality. You are entangled with everything you perceive. Your choices matter, not because they have some ultimate cosmic significance, but because your choices shape reality. When you choose what to attend to, you shape your experience and influence the reality you inhabit. When you choose to listen or to ignore, you participate in creating the world. This is not magical thinking. This is how consciousness works. The universe is participatory, and you are a participant. This is both humbling and empowering. Humbling, because it reveals that you are not separate from or above the world. You are woven into it. But empowering, because it reveals that you matter. Your consciousness matters. Your choices matter. The world is shaped by your participation in it. The problem still unsolved. After this long journey through sound, from ancient philosophy to modern physics, from the biology of hearing to the cosmos itself, we have learned tremendous things. We have learned how sound works. We have learned how it shapes consciousness. We have learned how it reveals principles that extend far beyond sound itself. And yet, the deepest problem remains unsolved. The explanatory gap between objective description and subjective experience persists. We can map every aspect of how sound is processed by the brain. We can show which neurons fire in response to which sounds. We can predict with precision the neural activity that will occur in response to any acoustic stimulus. And yet, we still cannot explain why this neural activity feels like something. Why does processing a specific pattern of vibrations produce the subjective experience of hearing middle C? Not just any sound, but that specific sound. This is the hard problem of consciousness. And sound makes it harder than any other phenomenon. With vision, it's possible to imagine that perception is purely about extracting information. But sound seems to produce subjective experience that goes beyond information. A sound has a felt quality, a texture, a phenomenology that seems irreducible to objective description. Some philosophers argue that this gap is permanent. There is something about consciousness that simply cannot be reduced to physics. Consciousness has properties that are fundamental and irreducible. Others argue that we're just missing something. That future neuroscience will discover how subjective experience emerges from neural activity. That the mystery will dissolve as our understanding deepens. But sound suggests that the mystery might not dissolve. Sound might be teaching us that there is a permanent gap in the structure of knowledge. That there are aspects of reality, particularly subjective experience, that cannot be fully captured by objective third-person description. This is not a failure of science. It is a revelation about the nature of reality. Reality has an objective aspect that science can study. But reality also has a subjective aspect that can only be known through experience. These two aspects are not reducible to each other. They are complementary. The objective and the subjective are both real, and they are both necessary for a complete understanding of anything. The problem of consciousness remains unsolved, and perhaps it should remain unsolved. Perhaps the unsolvability is part of the truth. Perhaps consciousness is supposed to be mysterious. Perhaps the mystery is what makes consciousness precious. The fact that experience cannot be fully explained or measured or reduced means that experience is not just information. It is something more. Something that matters in a way that information alone cannot capture. In studying sound, we approach the deepest mystery of existence. And perhaps the right response is not to eliminate the mystery, but to learn to live with it, to honor it, to recognize that consciousness, the lived experience of sound, of beauty, of meaning, is irreducibly precious, precisely because it cannot be fully explained. What sound teaches about consciousness? Sound teaches us many things about consciousness. First, that consciousness is fundamentally about relationship. Just as sound exists in the relationship between vibration and ear, consciousness exists in the relationship between mind and world. Consciousness is not something that happens inside the brain in isolation. Consciousness is what emerges when a mind engages with the world. Second, that consciousness is participatory. Your awareness shapes what you perceive. Your attention shapes your experience. You are not a passive receiver of reality. You are an active participant in creating it. Third, that consciousness is temporal. You cannot perceive a sound all at once. You must predict the future and remember the past. Consciousness unfolds through time, and the flow of time is not objective. It is experienced differently depending on attention and emotion. Fourth, that consciousness is embodied. You don't hear sound with your ears alone. You hear with your entire body. Your body resonates with vibrations. Your body remembers through muscle memory. Your emotional response to sound is a bodily response. Fifth, that consciousness is emotional. Sound moves us. It affects our hearts, not just our minds. Meaning is not purely cognitive. Meaning is emotional. Consciousness is the integration of mind and heart, intellect and feeling. Sixth, that consciousness seeks meaning. Humans create music, not because it helps survival, but because consciousness is driven to find meaning. Consciousness inherently seeks significance, pattern, order. Consciousness wants to understand. Seventh, that consciousness connects beings. When people resonate with the same sound, their brainwaves synchronize. Consciousness can extend beyond the individual. Community consciousness, group consciousness, collective consciousness are not mystical ideas. They are neurological realities. When people resonate together, their consciousness merges. Eighth, that consciousness has limits. You cannot perceive all frequencies. You cannot attend to everything. Your consciousness is a narrow spotlight in a vast landscape. What you perceive is not reality as it is. It is reality filtered through the limitations of your consciousness. Ninth, that consciousness is mysterious. The explanatory gap remains. There is something about subjective experience that resists complete explanation. This mystery is not a limitation. It is the nature of consciousness itself. Tenth, that consciousness is precious. The fact that experience matters, that beauty moves us, that meaning is possible. These are not accidents or byproducts. These are central to what consciousness is. Consciousness creates value. Sound teaches us all of this because sound is simultaneously objective and subjective, physical and psychological, universal and individual. Sound is what consciousness encounters when it meets the world. And in that encounter, the full nature of consciousness reveals itself. The future of understanding. We have come far in our exploration of sound. We have traced it from ancient philosophy through modern physics. We have seen how sound reveals principles about reality that extend from the quantum realm to the cosmic distances. We have learned that sound is not peripheral to understanding reality. Sound is central. Sound is how vibration, the fundamental principle of existence, becomes knowable. But the future of understanding might take sound in directions we have not yet imagined. As technology advances, our capacity to listen will expand. We might develop instruments to hear gravitational waves with greater clarity. We might listen to the vibrations of distant exoplanets. We might develop brain-computer interfaces that allow us to hear frequencies we cannot naturally perceive. We might create new forms of music and art that we cannot yet imagine. As neuroscience advances, our understanding of how consciousness processes sound will deepen. We might discover new aspects of how the brain constructs experience. We might find ways to help people with hearing loss or auditory processing disorders. We might understand more about how sound shapes development and learning. As philosophy continues to grapple with consciousness, sound will remain a crucial window. Sound reveals the nature of perception, the role of attention, the bridge between objective and subjective. The study of sound might eventually help us understand consciousness itself. What seems clear is that sound has only begun to teach us. The lessons of sound extend into every discipline, every domain of knowledge. The future will likely see sound playing an increasingly central role in how we understand reality. Not because sound is the whole story, it's not. But because sound illuminates principles that apply everywhere. Because sound connects us to the deepest levels of reality. Because sound reveals that reality is fundamentally creative, fundamentally relational, fundamentally alive. In the end, the study of sound is the study of existence itself. It is the study of how consciousness encounters reality and creates meaning. It is the study of how the universe becomes aware of itself through the ears and minds of conscious beings. And that study, it seems, has only just begun. The future will bring new questions, new insights, new mysteries. But the fundamental lesson will remain: listen carefully, because the universe is speaking. It is speaking in the language of vibration, in the music of existence itself. And consciousness, your consciousness, is the universe listening to its own voice.